Good afternoon, sir.
Good afternoon, ma'am.
Welcome, sir, for the session, and we are very grateful to you that you spare your time on a holiday. So, shall we start, or should
Yes,
we
we will
wait
start
for
the
more
session.
attendees to join?
No, we will start the session.
So, if you allow, can we start with a short introduction of yours?
Yes, ma'am.
Okay. So, dear participants, we have our expert for the session. This is Dr. Vijay Kumar. He is Associate Professor and Head of the Department, Information Technology Department. In NIT Jalandhar, Punjab, and he has received his PhD degree from NIT Kurukshetra and his MTech and BTech from GJU SNT Hisar and Kurukshetra University, respectively. He has served more than 3 years of teaching and research experience at NIT Hamirpur. And prior, he had 12 years of teaching experience in various reputed institutes like Manipal University, Jaipur, and Thapar University, Patiala. He has completed 2 DST SERB and 1 CSIR sponsored research projects. Presently, he is working on one BIS project and he has published more than 190 research papers in international journals and conferences. He has various book chapters also, and he has supervised many PhD and MTech theses on meta heuristics, image mining, and data clustering. And his current research area is soft computing, data mining, deep learning, steganography, and pattern recognition. So today we have Dr. Vijay Kumar with us, and now he is about to start the session. I hope it will be very fruitful to all of us. So thank you so much, sir. And the audience is all yours. You can start the talk.
Okay, thank you so much, ma'am. And now we'll start the session. I think my PPT is visible to all of you.
Yes, sir, it is
Yeah.
visible.
Another today topic is that exploring the generative AI, the deep
Sir,
dive
can
in
we make it
the
a
yeah,
slideshow so that it will be
yeah.
full screen?
It's on the full screen.
Oh, it is showing me the various slides in edit mode.
Okay, just a minute. I will share the whole screen. Now it is visible.
Yes, sir.
Uh, so today topic is that exploring the generative AI, the deep dive into the creative will be there. And in that session, we will discuss about the what do you mean by the generative AI and how it is applied in the different domains will be there. In that case, we will mainly targeting some introduction to the generative AI. Then we'll discuss about some generative models will be there, which models are more appropriate in the which scenario will be there. Then how will designing the generative AI models, what is the need behind the generative model, and then the application of some application like either medical will be there, either some business will be there. We'll discuss about some general applications of generative AI. And after that, we will discuss about what are the main challenges in the different domains, either when we're talking about the deep fake detection techniques, and either we have to go for some bioinformatic will be there. So, like, what are the main challenges in our the generative AI? Then we'll discuss about some of the ethical implications. Means sometimes some ethical considerations will be required. So, in that case, we will add some ethical considerations in our the generative AI. And thereafter, we'll discuss about some future perspectives will be there and statistical analysis, how the generative AI is the more popular and more effective in our scenario will be there. And next will the before starting, what do you mean by the generative AI? You should know about what do you mean by the AI, because nowadays we will see AI is much more popular every time when we apply some project, when we design some methodology and technique. In that case, AI is required. So before starting the generative AI, we must know about that particular first terms. I think my slide is movable.
Yes, sir, it is visible.
Yeah. Okay. Before starting about the generative AI, we will discuss first about that AI will be there. Like AI means it is a technique by which we will say that this machine will be replicated like a human beings will be there. And when we say that our machine will be behave like a human being, it means some learning behind this. And when we say some concept of the learning will be utilizing, it means we will design some model, some algorithms will be there because we'll say like machine learning models apply, deep learning models is apply, yeah, to modify some scenarios will be there that will be applied in the different domains. So for that case, some concept of the learning will be required. When we say that the learning, it means the machine or some robots that will be learned from their environments. And when we say that learning will be applied, in that case, mainly we will target some tuples will be there, and they will learn from some experience. That experience mainly will represent by the E attributes will be there, and that learning will be either from the environments, either we will say it will be from the training data will be there, and sometime we will say some interactions with the particular machines. So first attribute when we say that learning, it means we will take the data experience from the data from the environment and interaction. So first attribute is E will be there. Second one is that when, for example, if we design some machine, in that case it will be designed for some particular task, and we will not say that one machine will do each and every task will be there. So first one is that we will say that machines and some particular algorithms that will be designed for some specific task will be there. In that case, another attribute is tree. This is the task will be there, and from which we will utilizing the learning concepts. And another one is that performance, the P metrics will be required. So we'll say that our learning concept will be behind these three tuples like a task, which task we will require, which type of the experience will be required. And thereafter, when we design something, in that case, the performance is measured either in the term of the accuracy, precision, recalls will be there, and sometimes some other performance measure will be also there depending upon their application and research domains. And when we design something, in that case, we will identify that yes, performance is up to the mark or not, or we'll say that it is within the specified limit. We'll say within the specified limit, it means it is appropriate. Otherwise, we have to modify. Either we have to modify the models will be there, either we have to modify some training data will be there, or some environments will be there. So when we say like our machine will be behave like human beings, so in that case, we'll require some learning concept, and that will mainly targeting with these three tuples. And when we say that AI will be applied in that particular domain, but now the times we will say that AI is applied in the every aspect of our life. For example, when we see some movies and some videos on the Netflix, in that case, some AI techniques means either the machine learning or deep learning techniques will be utilizing, and they will generate the revenue. For example, the Netflix will generate the revenue from 80 to 85% from the recommender systems, and they will analyze your the searching histories will be there, which movie we will prefer in particular times. If some particular war movie we are interested in the war movie, in that case next time we will open the Netflix, in that case that will recommend these war movies will be there. If we are interested in some other types, in that case that will be recommend. Similarly, when we go for some either the Flipkart will be there, Amazon will be there. Again, the recommender system will play the big role to generate their revenues. And most of the time, we are interested in some particular laptop. And after saying on the Amazon, we will close this window. And the next time we will searching some on our the Google. In that case, sometime they will recommend the system will recommend that yes, that particular item is more appropriate in that particular site will be there. So likewise, each and every today's life, we will apply these machine learning techniques. Machine learning techniques mean these are come under the AI parts will be there. So we'll say the AI means analyze the large amount of the data, and after that they will analyze the patterns that are available, and based upon these patterns, we will go for our decisions. Next one, this is another some examples of the AI will be there. This is a background we will mention like a the first well-known applications of the AI. This is the Alpha Go will be there. This is well-known is Google's Alpha Go. This is applied in one particular games, and that will become under the reactive machines. Similarly, that Deep Blue will be there. That will be apply come under that particular reactive machines will be there. Now you will already know about the Shri will be there. We have to ask something from the Apple Shri. In that case, it will respond. The Apple Shri, this is another example of our the AI will be there. Just playing computer, Tesla self-driving car will be there. If we have to go somewhere, in that case, previously we have to stop the car and stop the vehicles, and we will ask the particular places. But now the times we will apply the Google Maps. In that case, we have to place the particular locations, and then Google Map will be provide the directions. Similarly, the two depth cameras will be there. Chatbots are more popular nowadays, and the optimized search engine. So these are some only some examples of the AI. Otherwise, AI apply on the every aspects of our life. Next one is that AI evolutions will be there. Mainly, we'll say that AI is evolving. It means they are mature will be there. But previously, we'll say like artificial intelligence, AI narrow intelligence, ANI is more popular previously. And that will say that stage one will be there, in which we'll say Shri, Alexa, and Cortana will be there. And they are specialized only the one area, and they will solve only one problems will be there, in which we'll say when we will target only the one application, one task. In that case, that will become under that particular stage will be there. This is called that artificial narrow intelligence, A and I will be there. Second one is the stage two. It means we will refer the computer that is smart as enough the human beings will be there. And that is called that artificial general intelligence will be there. For example, we design some algorithm that is applicable to some general applications. For example, you have already know about one term is a transfer learning will be there. For example, if you know to drive the cycle, in that case, this basic concept will be applied to learn about that bicycle will be there. So means, we, for example, if we learn something from the one domain, and these knowledge will be applied in the another domains will be there. That is called the transfer learning. In the COVID area, COVID times, we will say that most of the papers will be published by applying these transfer learning. Means either we apply the LXNet will be there, exception net will be there, mobile net will be there. They will be designed for the different application. But at the time, particular times, we will say that these will be applied on that chest X-rays will be there, CT scans will be there. So these type of the learning is called the transfer learning. Means we will learn something from the one domain, and that will be applied on some other domains. And only we'll say some modification will be done. So now the time we'll say like a artificial general intelligence means we'll design some algorithms, some models will be there, and that is more enough to work the different applications. So it is say the stage 2 will be there. Now the time we are only in the 2.5 stage. We'll say we have covered the stage number 2, but we will not able to reach on the stage number 3. Stage number 3 is called artificial super intelligence will be there, in which we will say like a machine questions will be there, means that is smart than that best the human brains will be there in the practical every fields. So we will say these concessions not apply till now in our machines. So we have reached the 2.5 will be there. So this is the three types of the AI. First one is that artificial narrow intelligence. Second one is artificial general intelligence. And this is the last one is called that artificial super intelligence will be there. Next one, the question is that when we talking about these AI, in that case, is again the two type of the AI. First one is that weak AI and strong AI. Weak AI means that will be narrow applications will be there, limited scope will be there. When we go for like a strong AI, it means they have the wider application as compared to the weak AI. It means it will be like a human beings, it will be think like a human beings will be there, and it to behave like a human beings. Means we'll say it will replace, we will not say that it will replace the human beings, but it will help to the human beings. So we'll say the application has incredible human level intelligence will be there. But when you go for the weak AI, it means your application is good only on some particular task will be there. Means because we have designed these type of the devices and algorithm only to some specific task will be there. And in that case, we will say mainly the supervised and unsupervised learning approach will be used to process the data will be there. Next term is widely used now the time will the data science will be there, and we'll say like data science is more important than now the day. When we say the data science, in that case, we will require the three main fields will be there. First one is the programming will be there, the statistics will be there, and business will be there. Means all these three concepts will be applied on our the data sciences. Means this is we will say like we have to extract some meaningful insights from the data by applying some various tools and techniques or some fundamental concept of our the machine learning application. So that is called your data sciences will be there. And when we say like this type data science, that is a big umbrella will be there. Within these AI will be there, artificial intelligence, and within that particular umbrella we'll say like machine learning will be available, and within that particular we'll say deep learning will be there. Deep learning will say it is subset of the machine learning, and machine learning is a subset of the AI will be there, and AI will again come under the category of your data sciences. And as we have already mentioned about that recommender system that will be apply in our the Amazon, like product details. When we surf on our the Amazon website, in that case they will be captured. This data will be the like product details. Which type of the product we have purchased, what the name of the product will be there, ID product ID will be there, price, color, each and everything they will be captures. And after that customer detailing will be there, customer name, address, phone numbers, they will be captured, and beside that they will be also capture that search details will be there. For example, you are interested in that laptop, and after some time you will be search the printer will be there. In that case there will be some search detailing will be there, and we have to find out that customer log files and search files will be there. So likewise we'll say these are some search detailing will be required. And after that we will say some transactions log files, because when we have to do some transactions, in that case log file will be created. And for example we will always within the month, for example one particular customer that will be by 40,000 purchasing behavior will be there. In that case every time it will be recommend the product whose cost is approximate 40,000 and less than 40,000 will be there. So means that particular log file is much more important. For example, if some months you will purchasing behavior will be increased, 40 to 60 will be there. In that case, it will be also suggest according to your purchasing behavior. So likewise, this transaction log is again the very very important. Next one is that will tracking all the order details will be there, and beside these histories and other data. So we'll say all of these data will be applied in our recommender systems. Next is the data life sciences. In that case, first we have to require the business requirement, and after the requirement will be come out, then we'll say that data acquisitions, mean capturing of the data will be there, either from the card history, some comments, some user rating will be there. The data acquisitions will be there. From these data acquisitions, we will go for that data processing. And when we go for the data processing, in that case, we have to find out the missing value, because every data is not, we'll say, 100% correct. So some missing value will be there. So we have to tackle these missing value. Either we have to replace the mean values, median values, and sometime we have to use some probability function that replace these missing values will be there. And after that, sometimes some fake reviews will be also available. Some will say that your that particular product is much more appropriate, and we have to say that that particular product is more appropriate for you. And but sometimes it is not appropriate, and we have to remove these tasks. Another one is that we have to also remove this one, and in that case, we have to apply these techniques. Like unnecessary data will be there, and these unnecessary data will be removed, and we have to either replace some data, unnecessary data, and we have to remove these data. Most of the time, this data processing we will go for like either the dimension reductions will be there, and sometimes instance reduction techniques will be applied. And a well-known technique like a PCA will be there. In that case, that will be applied on the dimension reductions. Next one is the data explorations, means we have to find some useful patterns from our available data will be there, and there is another techniques will be applied. And after that we'll another one go for the modelings, means we have to find some optimal features, and based on these features we have to design some our models will be there. And another one is that we have to improve the performance of our models, because sometime when we design some model, in that case some parameters will be available, and most of the students will be not able to analyze that whether these are the parameter or these are the hyperparameters. And when we say that the parameters, means that particular parameter are the depending upon our training data, and hyperparameters, and we have to set before tuning of these data. So we'll say these are the some optimization things will be there in which we have to improve the performance. Next is that we will start the today topic, because these are the some basics will be required to start our topics. Now we are unable to identify that what do you mean by the AI, and there is a difference between the machine learnings and data sciences will be there. Now we have add one word is here, the generative AI, because AI we have already knows that it will be we'll have to make the machine like a human being. It will think like a human beings will be there. But we have add some word is here, generative will be there. It means it will be generate something. It means when we have to design some artificial intelligence models or algorithm that are able to generate some content, either it will be similar to, or we'll say, that is depending upon our training data will be there. For example, you have to go for the chat GPT and you will say that you have to write some letter for something. It will design the letter. But after that, you will also provide some other prompt will be there. No, no, we have to write that particular application on a particular field will be there, on that particular person will be there, and we have to add something. In that case, that particular application will be refined. So we'll say the generative AI means our algorithm as model that will be able to generate some new content, and these new content depending upon your training data will be there. And when we first will train the models, and based upon these training, that will generate some new model, or we'll say that will be not exactly same, but it will almost similar will be there. And most of the time we'll say like these importance, because it will enable to the machine to be creative will be there, because previously will this will not able to generate the data, and we have to write some our research paper and project. In that case we will simply apply the grammarly, that some check for the grammatic mistake will be there. But now the time we have to take some suggestions from the AI, that will be also provided that yes, our title is not appropriate, we have to add something. In that case that will be also suggest. For that case I'll go for like a chat GPT will be there, clad will be there, Gemini will be there. There's a lot of the generative AI tools. And similarly, we'll say that it will produce some noble content like image creations will be there. Sometime it will be create some text will be there and videos will be there. So most of the time now, if you will say we have some paid version of the ChatGPT, so in that case we will write something that that particular image you have to generate. So that will be generate data or images based upon your suggestions, and your prompt will be there. Next one is that because we say that it is a generative AI, though how it is distinguished from that discriminative AI. Discriminative means classify, that will become under that discriminative models will be there. And discriminative means we have to mainly focus on the classifier. It means we have to differentiate whether your data will be belong to class 1, class 2 and class 3 will be there. And but in the generative AI, our main aim is not that we have to classify it. Our main aim to find out some pattern that will be existing in the data. And based upon these patterns, they are able to generate the new samples which also exhibit the same type of the patterns will be there. So we'll say there's a difference between our the discriminative and generative models will be there. Generative means we have to able to generate the new data, and that data will be depending upon your training data will be there, and that exhibits some particular patterns or some properties will be there. And in the discriminative, only that particular task is that based upon the available patterns, they have to classify. Either it will be put on the class 1, class 2, or class 3 will be there. Next one is that type of the generative models will be there. When we have to differentiate, in that case, there is a three main category of the generative models will be there. And first one is a autoencoders. And we'll say this is the image will be there. This is the encoder part, and this is the decoder parts will be there. And there is some we will say this is a bottleneck. We sometime mention is the bottleneck will be there. When we say that auto encoder, it means that will consist of that two parts will be there, encoder and decoder parts. So the encoder means we will compress our input data into the latent space. This is the latent space will be there, means we will reduce the data will be in some representation form. And after that we'll say this information will be transferred to our that constructed images will be there. And it means there's a two type of the networks. First is the encoder, second one is the decoders. And first we will take some data. Data mostly we will take the images will be there, and that particular image will be transformed into the latent space will be there. And decoder network that will be transferred from these latent encoder latent space to our the reconstructed images. When we say what is the functions of the our encoder and decoder, so first we will take like a encoder. It means that will take the input data, and after that it will be apply the compressions on it. Compressions means we have to reduce the images from high dimension to the low dimensions will be there, and that is mostly we will already know about the latent space will be there. So first main function is that only that will be compress our image from the high dimension to the low dimensions, and it will consist of the multiple layers will be there, and each layers have the number of the neurons will be there, and every layers have their own specific task, and that mainly, and in every layers we try to progressively reduce the dimensionality of the data will be there. The main task is that we have to reduce the data dimensionality of the data will be there. Again, when we say that data reductions, that is common, the two parts will be there. First one, dimension reduction, and the data reductions will be there. Data means instance reductions will be there. And that particular time, we are talking about that dimensionality will be there. And decoders will say that we have to reconstruct, means from the latent space that we will reduce from the original data. We have to reconstruct the data from the latent representation. This is the function of our decoders will be there. And mainly we'll say that it is the main purpose of that structure is that it will gradually increase the dimensionality until it matches the input dimensions will be there. So first one task is that we have to reduce, second one is that up to the size will be there. And another part we will mention here the bottleneck. So what is the meaning of the bottleneck? What functions of the bottleneck? It means the compressed representation of the input data that is always located in the middle portions of our the autoencoders will be there. And the main task of this bottleneck, that particular portion, is that will be smaller than the input dimensions will be there, and it will force that encoder to learn the most of the important features. For example, in our PC we'll say that we have to kept only those features which have the maximum variations will be there. Variation in that case, we have to kept only the important features in our the latent space will be there. And the main property of this one is that under complete autoencoders will be there. It means bottleneck is intentionally similar to capture the essential features. Only the essential feature will be captured from the input data will be there. Next one will say that sparse autoencoder, because sometime we'll say like that will increase the sparsity in the latent representation for the meaningful features. Similarly, in the when we go for the variational autoencoder, in that case, probabilistic structures will be there, and that will enable the generations and interpolations. So we'll say these are some particular autoencoders type will be there. Either the variational will be there. Next category we will say the generative adversarial network GAN will be. It is more popular now the day, and in the deep fake it is widely used because we have, because now the time we'll say that deep fake is a major threat in our the real life scenarios. So the GAN is widely used in our the either the deep fake generations and deep fake detections will be there. When we say like again the three parts will be there. Generative, it means it will able to generate the new data based upon the training data sets will be there, and sometimes it will be, we will say it is similar to the data in which is trained. And another one, that name is called adversarial networks will be there. So means it will be generated, there is a two parts will be there when you go for that generative adversarial network. Means generator that is responsible to creating the new data, and the discriminator is responsible to distinguish between the real and fake will be there. And though it means this adversarials mean there is a game, mean generator discriminator that will be engaged in that zero sum game will be there. If one success, it depending upon the another one failures. If we say the generator is able to generate the image which is very real, approximate to that real image, it means we will say discriminator is unable to find out. So most of the time, so it is known as that adversarials, because the success of the one, that depending upon the failures of the others will be there, and it is a iterative process because they are trained simultaneously and each one try to outsmart each others. And many will say ideally they will reach on the equilibrium when will generator will produce highly realistic image. Actually these images are not the real one, These are the fake images. What it look like the real images will be there. And discriminator can no longer distinguish them from the real data. So we'll say this the convergence process will be there. And this is actually we'll say the structures. For example, these are the latent space, and from these we will add some noise will be there, and that will generate our fake images. This is the fake images will be generated. These are the real images. We will not provide that whole images. Only the latent space will provide, means some descriptive representation of that particular images will provide, and after adding some noise, that generator will be generate the fake images. The task of the discriminator is that that particular you have to check either these particular are the real or fake images will be there. And if we'll say the discriminator is accurate one, it means it is a fine, otherwise some fine tuning will be required for the both one, generator and discriminators. And generator, as we have already mentioned about the generator, that will be generate the new data, and that will resemble your training data will be there. I mean, it look like a real image or real data will be there. And beside these, it will take the latent space representations will be there, and after that, we will also add some noise will be there, and that will produce some synthetic data. And the main task of discriminator mean that will distinguish our the real data samples from the training sets, and fake sample that generated from our generators will be there. And structure is will take the data sample as input, and output means some probability, whether it is a probability of the 0% to 10% to 20% will be there. Another one is that another model that is called the restricted voltage machines will be there. RBM is very popular names will be there, and in which we will say there's a two layers will be there. First one is a visible layer, input layer, and hidden layers will be there. This is the visible and hidden. These are two type of the layers will be there, and each visible unit is connected to each and every hidden units. It means mesh will be created, mesh topology will be created, because each and every node is directly connected. For example, this is a node that will be say that connected will be there, and but no connection within that. There is a no connection between them. So we will say each visible that will be connected with another one, and sometime we will assign some probability based upon their energies will be there. And another one, this is the transform based models, and that is very well popular. But now the time will the chat GPT-4 will be utilizing here. And these transformation based models that have the mainly we'll say these are three main component. First one is that self attentions will be there. When we say it is self attentions, it means your model component to attend to each others and understanding the relation between the words and elements within the sequence, because that is important one will be there. For example, if we write like a hello word, in that case, these word organization is important within that particular sentence. Similarly, that position encoding is also important when we have to understand some language. So in that case, positioning is also important. Otherwise, the meaning of the sentence will be changed. The meaning of a word will be also changed. So it means this particular position encoding, that is the important parts will be there. And similarly we will say this is self annotations, that will be attentions models that are the important one. Next one is that layered architecture, because multiple layers of encoders and decoders will be applied, and that will apply only for the understanding, better understanding from the given data sets will be there. So these are the generative models will be there. If we have to design their own generative AI model, in that case, we'll say require mainly the six steps will be there. First one is analysis. It means we have to analyze analysis of the problem will be there. What type of the generative AI model we have to design? In that case, the particular requirement will be analyzed, and after the analysis of the requirement, we have to write our requirements. Then we have to require like a story generation concept will be applied. Next one is that designing will be there. If we are able to understand some problems and which type of the generative models we have to require, and after analysis, we have to go for the architectures will be there. Which type of the architecture is more appropriate in that particular task will be there, and which type of the data models we have to apply. So that will be required. And next one is that deployment. Where, for example, you have designed your models. In that case, we have to development will be there. Development means code generation. We have to generate the code for a particular models, and after the coding, we have to perform some debuggings will be there. So that will be done in our the development phase. And for example, we have to design the code for the particular models and debugging will be done. And after that, that will be test on the real environments will be there. In that case, we have to write the test cases and test code generations will be there. And when everything is fine after the testing, then we'll say it will be able to deploy. So in that case, that particular model will be deployed and automatic script writing assistance will be there. And sometime that will also possible that we have to provide some maintenance will be there, and for that case document generations and monitoring will be there. And next one is that why we need for the generative AI, because generative AI is widely used. First one is that image generations will be there when we have to generate some image. In that case, now the time generative AI will be applied. Similarly, that text generation, ChatGPT is widely used in each and everywhere. This is applying the text generations will be there. Next one is style generation. Style transfer will be there, and style again we will generate the styles will be there. And if we have to modify the images, we have to modify the videos. In that case, face aging and de-aging that will be also apply. And presently we will say the mostly work will be done on the deepfake technology. So these are the some main five application where we apply these generative AI. First one is that image generations will be there, because image when we have to require the data, in that case the image is the one major sources will be there. And widely deep learnings are widely applied on our images and videos will be there. So in that case, with in image generation, in some particular applications, AI will be allowed to generate their own images will be there, and some images which are not foreseen images will be there. Only based upon the description, we have provided some descriptions will be there and data will be there. They will be generate the images for you. And in that case it will be generate the images for the peoples, animals, some landscapes will be there. So different type of the data images will be generated. And similarly the style will be also including, like which type of the specific angle we will require, which type of the lighting will be required or will be done during that particular image generation. Similarly we will have to again the emotion tune that will be also added here. Either we are aiming for the joyful will be there, screening will be there, eerie will be there. Likewise, we'll say these emotion tones that will be also add up on the image generations. So in these are the well-known platform. If we want to generate the image generation, in that case, these are the tool. Like Jasper is widely used. Straight Eye will be again the another tools will be there. And next, the mainly we'll go for like a deep dream generator, deep AI, and DALL-E will be there. And mostly these are widely used, and another one these Night Cafe and Bamboo that will be also there. And when we have to differentiate between these platform for the image generation, like a Jasper Art that will be available on that particular website, like Jasper.ai, and we are available the 7-day trials will be there. If we have to go for the premium, in that case that much amount you have to pay. And if you have to create the images in the different style, in that case Jasper is a very good options for you. And if you have to go for the image upscaling, in that case you will go for like a mid journey will be there, and you have to pay because this is not a free software. Mid journey you have to pay that amount per month will be there. Like similarly we'll say like a Dell E2, this is discontinued now the day. Open AI, the Dell E2 previously we are using, that will be generate some copyright free images will be there. Stray AI will be there, that will be provide only the free 5 images per day. If you have to modify some images, generate some images, customize some images, in that case only that will be apply for the 5 images per day. After that you have to pay for them. And next one is the Dream by the Bumbo will be there. This is the www.d.ai will be there. This is a free, and that will provide again the 3 artwork per day. After that you have to pay some amounts will be there. So these are some platform for image generations. And similarly the Night Cafe will be there. This is the free sign up will be there. Again we have some small amount we have to pay for generative creative. AI will be there, images will be there. Next exercise X will be, and that will provide the 50 images per month. For example, you the limit will be off. In that case you have to pay some small amount. Similarly the Pix array will be there, deep dream generators, and deep AI. This is the widely used. Deep AI is widely used to generate the images. This is the free but limited customization is available. You have to use the full version. In that case, you have to pay that particular amount will be there. Next one is the text generations will be there. We are widely used like a chat GPT will be there, Brad will be there, and Gemini AI will be there. So a Clad will be there. These are come under that particular category like a text generation. And for example, sometime we will struggling about to find out the right words because that particular title is available. In that case, which title is more appropriate? We will write the project. In that case, the we are unable to find out the particular right word, and if we will write something and that is available, in that case that particular that will be helpful for us for generating the text. So in that case the AI will be create some narratives and some catchy blog posts will be there. We will send it able to write the code for your projects, but these code are we have to customize according to our needs. And so it is a clear and concise prompts will be required. For example, if you write something, it will generate the data, and based upon the output of the data you will again you have to customize your prompt will be there. Next one is that it will provide the speed text, provide some initial some sentence or paragraph. It will be able to guide yes we are on the right direction or not. If we will say that this is our project titles and we will write something, in that case that will provide the data, and we will say that yes we are not in the right direction, we have to revise it. Similarly that context and examples that will be also show some relevant references, but now the time if we will provide the data it will show that yes these are the relevant references or not. So likewise, these text generation techniques are more powerful nowadays. Like a chat GPT is very well known 4.0, and other advanced version is come recently. The Brad will be there by the Google, Jasper, Copy AI, Gemini will be also there, Clad will be also there. These are some text generation tools. And if you have to find out these Brad, in that case you have to write here the brad.google.com. In that case that you have to find go directly to that particular website, and these are the website for the ChatGPT 4, Jasper, and Copy AI will be there. And when we say the Brad, that will be use the this is a particular PLM will be there, and Mina. These are the model that will be utilizing in the bread. When we go for the ChatGPT 4, in that case GPT 4 will be utilizing, there is come under the Open AI will be there. And Jasper is use their own customized transformer based Jasper AI will be model will be there, and Copy AI use the various LLM model and customized models will be there. And when we go for the terms of the language, in that case Brad will be support more than 40 plus images, but in the chat GPT that will be provide 50 plus images, and Jasper will support 26 images, and Copy AI that will provide support the 27 images will be languages will be there. So these are the languages, the different languages will be supported. 40 plus maximum the chat GPT will be support, like 50 plus languages it will supported by the chat GPT-4 will be there. Access is again we'll say, again we'll say it is a free will be there, and limited access, but there is a paid pro plans will be there. Again we'll say it is a free for some limited access will be there. After that you have to pay for the chat GPT 4 will be there. And on Jasper and these Copy AI that will require that paid subscriptions. Next one is that main focus is that either research oriented or general purpose write up we will require that both the bread and chat GPT. But when we go for some copyright marketing, copywriting content, in that case we'll go for the Jasper. Similarly, when we have to write some content according to the marketing and sales copywriting, for that case we'll go for the Copy AI will be, tools will be there. And when we go for the limitation, in that case it can be only with technical and formal will be there. But when we go for the chat GPT, it will always mentions that it will produce some data, but is again it is some factual error will be there, and sometime biasing will be there, and customization will be required. So that will mention that don't blindly trust on the chat GPT or Brad, Jasper, and Copy AI. You have to check whether you will get the right content or not. So first you have to verify that data will be there. And similarly, the Jasper that will make the may lack the flexibility for the non-marketing task, and high cost will be there. Similarly, we'll say when compare that Copy AI that will only focus on the marketing, not on the selling will be there. So likewise, these are some limitations of these particular test generations. So don't blindly trust that yes that will provide the correct data each and every time. Now the day will say like if you have to write some question paper, the teacher will be put the particular content and directly go for the printing. So before applying these ChatGPT and Brad, you have to check the validity of the questions will be there. And after that, you have to also check the validity of the answer provided by the ChatGPT or Brad will be there or copy AI will be there. Don't blindly trust that these are the accurate one. So you have to first validate whether the results provided by these text generators are accurate or not. Next one is the style transfer will be there. Another domain is that we'll say this technique will be blind the content of the one image with the artistic style of the another one will be there. In that case, we mainly use for like that is mainly targeting for the music, text, and video. So these are the three main target in that particular style transfer. And when we say the style transfer, it means we will take the content image, then we add up the style image. In that case, some styled image will be created. So we'll say that the picture you want to transform in that if another one will provide another image that will be infused on that content image and that will be converted into the stylized image will be there. So we'll require the two type of the images will be there. For that case again when we go for that style transfer there is two well-known platform. This is called that Deep Dream Generator and the Prisma will be there and that will be applied for that style transfer and in which we'll say the Google Deep Dream algorithm that will be widely used in that particular Deep Dream generators. But when you go for the Prisma, in that Prisma Labs, that will be used the combination of your the neural network and artistic filters will be there. And when we go for the advantages, in that case, that will generate that dreamlike and surreal images with the deep neural network styles, and they will customize options will be also able. Different layers will be there. In that case, based upon these layer selections and strength, you can customize that options, and you can also create their own artifacts or visuals will be there. And these particular platform will be able to provide the sharing and generating the images. So these are the advantage of your the deep dream generators. When we go for the Prisma, in that case, some art because we have mentioned the artistic filters will be there. So they provide a variety of artistic filters, and that will be inspired from different artists, and that will be applied. And similarly, we'll say that these real-time transfer, style transfer, will be also available for the videos and audios will be there. And these particular Prisma have a very user-friendly interface and that can be easily shareable and that can easily use by the user. So when we go for the limitation, it will require that network. When we go for the deep dream generator, that will require that internet connection for the processing. But in that case, we'll say because that is installed on our systems, and in that case, net will be not required. Only the limited. Again, the problem is that only limited free filters will be available. You have to go for additional feature. You have to pay the payment. Only some limited when we have to take some filters. In that case, these are not appropriate. We want to some additional filter, so we have to pay for them. Similarly, we'll say that output is heavily depending upon the input image will be there. If your image is not a good quality, then we are not able to enhance on the particular labels. But in that case, we'll say some style may produce the result that are less faithful to the input image. Means some artist are styles are already available and that will produce a very better results. And features, when we compare in the terms of features, in that case the feature is inspired from the that particular famous artist will be there, Van Goghs will be there and Bescos will be there. And in some in-app cameras will be also there for the real-time style transfers. And there is also option that you transfer the turn your photo into art forms and apply the style to the video also. So these are the main advantage of your Prisma will be there. When we go for the deep dream generator, in that case, the community gallery will be provided and it will be also powered by your the Google's deep neural network algorithms. And it will provide the multiple style options will be there and multiple layers customization options will be available in your deep dream generator. Next third category is called that your face aging and de-aging will be there. In that face aging and de-aging that mainly used for the generative AI means we have to modify our images. Means when we go for the aging, it means that will be add some wrinkles and sagging the skin will be there, gray the colors will be there. Means that will be predict like how that particular person will be appear in the next 20 years, 30 years, or 40 years will be there. Similarly, like when we go for the de-aging, it means we have to reverse that particular part will be there, regenerate the faces in the images. That will be remove the wrinkles and restore the youthful appearance will be there. And that is mainly popular in our the entertainment and personal photo editing. As we have already know that when we take the camera, we will take the picture. In that case, we will apply different type of the filters, and they will remove the wrinkles and they will be enhanced. Their brightness will be there, so all will be there, done in our the available camera. Mobile phones will be there, and in which we'll say different type of the apps will be available, like a beauty app will be there. So there is some app that will be modify your images. So likewise, in the face aging that is widely used in our the gaming and storytelling in movies. So in that case, when we apply some visual aging, that will be applied in our the in that particular areas. When we go for the platforms like beside these platforms, some other platform will be also available like a face aging and defaging. First one is a deep face lab will be there, and that is the open source deepfake creation tools is available, in which will deep learning technique that will able to swap that face swapping will be there, and in which face reenactment will be there, and it will also support the both image and video manipulation that will be done in our the deep face lab. But when we go for the face app, it means that is the AI powered photo editing app will be there, in which aging, de-aging, gender swapping will be also available in that face app. And this is a user friendly app. And beside this, it will be also provide some real time preview when we apply either the phasing, aging will be there, de-aging will be there. This is the face app. You can use this one. Another one is that regenerate by the Vens AI. It means that will be utilizing the AI based face aging, and digital tool will be also available. So again, it is a user friendly and it is a realistic, produce a realistic and natural looking results will be there. And beside these, it is important when processing the multiple image simultaneously. I mean, batch processing will be applicables. So these are the platforms comparison will be there. And next one is that we will go for like a deep fake techniques. When we say this is a very popular now the time, we will say some images will be recaptures and they will modified. So we'll say like a deepfake represents the seemingly authentic portrayal of some people saying and doing the thing they never did. And we'll find out some latest examples in the USA elections and Indian elections. The widely used these deepfake technique in the different domains will be there. And when we have to detect these deepfake, in that case, we have to go in these three scenarios. First time is that we have to check the unnatural face expression and lip movement will be there. Means deepfake detections that will struggle to perfectly replicate the human movements will be there. Means face expressions and lip movement that are totally different, and inconsistency in lighting will be there. If we look for the inconsistency in the shadow and reflection, so in that case that will be defy the physics law will be there. So again we will find out some inconsistency in lighting and shadow. We are able to find out, yes, that particular image is your deepfake image. Next one is that the audio and video mismatching will be there. So we will have to find out like a audio sound natural and synchronize with the lip movement. So we have to pay some attention. In that case, we are able to analyze. But now the time we'll say different type of the tools and techniques are available, and they are the again the modified or they are enhancing, and in which we are unable to find out that yes that particular actually image is either deepfake image or real image will be there. So now the time we'll say like a deep fake detection software. The company like Deep Trace and Verif AI are developing the tools that are able to detect the deep fake with the varying degree of accuracy. That will mentions that it is that particular accuracy will be there, and if we are able to detect the deep fake. And beside these, media literacy initiative means some education programs are crucial to equip the public with the skill to critically evaluate the digital content will be there. And in some time you will say post some on the LinkedIn, because most of the time we will say that our population is spending most of the time on the social media, either the Facebook will be there, either LinkedIn will be there. When we do something, in that case, we'll put on the LinkedIn, we will put on the Facebook will be there. We want that we will become famous by spreading our informations. But we have to put the least information on our LinkedIn or our Facebook, because someone can easily utilizing these information against you. In the previously, you will say like a victory sign will be look like this one, but another time the victory sign is totally changed. We'll write this one will be there, because when the we will use like this symbols, in that case the high definition camera will capture your the fingertips will be there, and the fingertips will be contain your the fingerprint will be there. When we are able to capture the fingerprints from the high definition camera, in that case we can easily access your each and every information, because your every bank account details that will be linked with your Aadhaar card, and that will be linked with your the fingerprint will be there. So we'll say that we have to wisely use these technology, because these technology are developed only for we have to do our work very in simple ways, and they will be helpful for us. But we will not wisely use, in that case that particular technique are also harmful for us. So we have to wisely use all of these techniques which are available. You will also know that okay, like most of the time crimes will be there. So we have to check each and everything, and we have to smartly use our devices. We not say that we are using our smart devices, but we have to also become our smart, so that these device can wisely use. When we go for like a deep fake, these are the in that case we will say mainly the four type of the deep fake faces will be there. This is that entire face synthesis will be there, in which will this is the real one, this is the fake one, that will be done. Next one is that attribute manipulation, means some, for example, this is particular one person will be there, some hair will be added on that particular image, some specs will be added here, some modification will be done on that particular parts will be there. Similarly here the modification will be done. So it means either we'll say that entire face synthesis will be done. A second portion is that when we go for the deepfake, in that case either some attribute will be manipulated, some here will be manipulated, some portion will be manipulated. This is called the attribute manipulation. And sometime we will say like identity will be also swapped. For example, we have take this image as a source image, this is the target image. After combining these images, this new images fake image will be generated. So I mean this is called the identity swap will be there. Similarly, like these two image will be modified, that will be new is generated. So this is called the replacement will be there, or identity swapping will be there. Another one is the expression swap, and that will be also known as that reintact will be there. Means these are the source and this is the target, and that will be convert on that particular this is the expression. These expression will be modified. So likewise, sorry, in our deepfake mainly we'll say like a four type of that deepfake faces will be there. Entire face synthesis, attribute manipulations will be there, identity swap will be there, and expression swap. So these are we'll say like a four type of that swapping will be there. Next one is that we have some. These are some snapshot we have taken from the different scenarios, like deepfake, deep media is a new security battleground will be there. Deepfake enter the Indian election campaign, and these are some other newses about the deepfake. So now the time will say the technology is advanced. In that case, the deepfake is apply on the different fields will be there. Next one is that what is the use of these deep fake? So that will be going that these three terms will be there: psychological harm, extortions will be there, defamations will be there, bullying will be there, undermining trust will be there. That will be the psychological harm will be done. And for example, you will write something, and my personal request is that you will don't allow the LinkedIn in to comment each and everyone. Only allowed that only your connection will be comments on your photo or your post will be there, because anyone can particular put the comments for you, and something else will be there. So that will be goes for your psychological harm will be there. So don't put each and first of all, don't put each and everything on your social media. If you put on the social media, in that case that will be allowed only for your friends will be there, don't for everyone's, though that will be required here. And the next one is that financial harm will be there, as you have already know. In the cyber crimes, we will say extortion will be there, ransomware. We will install the ransomware on some systems will be there. In that case, the hard disk will be encrypted until or unless we will not provide some money. In that case, they will be not encrypt. You are unable to encrypt your decrypt your data will be there. So we'll say like extortions will be that will required. Some identity theft will be there, fraud that will be also done by the deepfake, stock price manipulation, brand image, and reputation damage will be there. That will be all come under the financial harm. And then the society harms means the social media manipulation, damage to the economical stability, damage to the justice system, scientific system, erosion of the trust will be there, damage to democracy will be there, manipulation of elections, as we have already seen these things in our the Indian elections. And similarly, the damage to some international relations will be there in national security. So these are, will say, some harm will be done by these particular deepfake images. And these are the images will be there, and we have to find out which faces are fake and which are the real one will be there. So in that case, we will require our models will be there, so that we are able to find out, yes, that particular faces are the real one, this particular faces are the fake one will be there. When we say like a deep fake, in that case quality is rapidly improving will be there. For example, 2004, these are the quality. If we will going on the another one part, in that case deep fake generation techniques are also improving, and in that case we have to also improve our the detection tools will be there. The detection tool, the modification will be not done. In that case, it is not able to identify whether the data is your the real one, or we'll say it is a particular fake one will be there. So when we go for like these are some models will be widely used. This is called like RNN will be used in our the deepfake, autoencoder and decoders will be there, cycle GAN will be there, and generative and descriptive say pix to pix that will be applied in our deepfake. And when we go for like how the deepfake will be generated, for that case we will go for the GAN. GAN is widely used to generate the deepfake detection. Generations will be there, as well as it will also use for detection will be there. This is generator and discriminators. And when we go for this is the, for example, the driver or identity will be there, and in that case we will first crop the images. For example, this face will be cut down, like we have to detect this face, and then we will remove some background images and some other portions. And after that we have to intermediate representation will be there. For that case, first we have to go for the landmarks will be there, key points will be there, and then we have to find out some boundaries, like these are the boundary part will be that we have to go for the boundary part representation, and some parameters will be also there, and from these image we will also compute the UAV map and depth map will be there. And from these representation will not apply directly of these images, only these representation will be apply. This latent space representation will be there. From these will generate these images, and these image will be blind with that particular image. In that case, these images will be generated. This is the generated image. So this is the process that we will generate the deepfake. If we have to generate the deepfake, in that case I will go for that facemagic.ai platform will be there, faceswap.dv, this is the platform will be there, javdownload.com will be there, and hey reface AI, that will be also there. These are, we'll say, different type of the app, or we'll say websites will be there through which deepfake will be generated. And next we'll say like a deepfake landscape detection approaches. For that case, we'll go for the psychological signals, in which blinking informations and some we'll say 3D head nose features. From these we are able to identify that these are the deepfake data. And similarly we'll say we'll go for the artifact based detections, in which limited resolution blurring will be there, local artifacts like a eye, teeth we are able to identify. And sometimes this face x-ray means blending artifacts that are able to identify. So these are some deepfake images will be there. And when we go for the deep learning architecture, in that case either the Masonet, exception net will be there, capsule network, recurrent convolution networks, and transformer. Now the time we will say widely used, the transformer is widely used to find out these defect detection. And when you go for like a frequency domain, in that case local frequency statistics and spectral distributions and two-stream approach. So these are apply for the detecting these defect detection. So again, when we have to work on this deepfake landscape, in that case, this different type of the data set will be available. So large scale data set, this is the DFDC will be there, CoDF will be there, open forensics. So these are synthetic images. In the realistic, we'll say wild deepfake will be there. Classical, we are using the face forensic plus plus, and the limited one. These are some another one data set will be there. And if we have to design some algorithm, in that case, we'll go for like a deep detection, defect detection challenges that will be able on the Kaggle defect detection challenge will be there, in which the main goal is to detect the video with the facial and voice manipulations. And in the particular challenge, 2114 image teams participate in the challenge, and mainly we'll say this is a log loss error evaluations on public and private validation set will be there. So if we have to require to generate some new algorithms, in that case that will participate in our the deepfake detection challenge in our Kaggle. A limitation is that hard to spot every realistic manipulation from our methods will be there when we involve some manual tuning, and post processing will be there. But now the time this current version cannot detect manipulation in fully synthesized image. Like when you go for the style gain will be there, and latest style gains will be there. So we are able to, unable to detect that yes, this is some defect will be there. So in that case, the defect score is very less when going these particular scenario. What are the main challenges the defect detections techniques? In that case, computational resources will be required for the both the training and some serving request will be there. And another one is that user interface should be easy to understand. Some data will be captured and they are able to understand what is the actual output will be there. And beside these, we have to defend against the adversarial approaches will be there. These are the challenges we have to go for these deepfake. Next one is there some applications of the generative AI. When we go for the generative AI application, this is apply in the healthcare will be there. We will also apply in the retails, media, entertainment, educations. Also apply in our fashion, manufacturing, and the banking and finance will be there. When we go for the healthcare, because we have mentioned the word is a healthcare, so where we have to apply, so it will be apply on the drug discovery and development will be there. Like in the COVID-19 scenario, we'll say is like some existing drugs will be utilizing to defend that particular virus. So similarly, some new drug discovery will be required for upcoming viruses will be there, upcoming disease will be there, and sometime drug repurposing will be also required. So for that case, generative AI will be utilizing. Similarly, some predictions will be done. Either some when we provide some input image, either the X-ray, chest X-ray will be there, CT scan will be there, MRI images will be there, ultrasound images will be there. In that case, we will require some tools that are able to predict that yes, that particular disease will be there or not. Next one is that medical imaging analysis will be required. In the medical imaging that will widely use, for example, we'll provide the image and that will provide some descriptions about that image will be there, and that will also provide that yes, that particular scenario will be there. Next one is the genetic research and development in our gene therapy. That is the important one. Now that the work is going on, that particular gene therapy will be there. Next is that retail. When we say that generative AI, that will be the product design, which type of the design will be required, and that will be also create some personalized the customer experience will be there, and predicting whether the product demand on particular location or not. So likewise, that will apply in our the retail. Similarly, in the bank or finance, like credit card fraud detections, that will be applied. Risk may assessment will be there. Portfolio assessment, for example, someone apply for the loan, in that case their portfolio analysis will be required, and we have to apply for the credit card. In that case portfolio will be assessment. So likewise these will be done by our the generative AI. Next one is that media, like a film and gaming design, either the aging will be there, de-aging will be there, and the face swapping will be there. Each will be done by these tools. So generative AI is widely used in our the game and the film design and the music compositions. We will also apply these generative AI, and that will be also helpful for the personalized the content recommendation will be there. Next one is that product designing. We have to design some products, some new designing will be required. In that case, generative AI will be helpful. Sometimes some process will be there and some optimization will be required on that particular given process. In that case, the generative AI is more powerful in that particular scenario. And sometime you have to predict the maintenance on the manufacturing industry. So these are the area where the generative AI can be applied. Similarly, in the education, now the time will BioGeo or the online platform will be provided. So adaptive learning will be there. Depending upon the learning style of the person, you can particular video can be enhanced on a full speed or some smaller speed will be there. Some question will be asked on the different uh, aspects will be there. Audio education content creations will be there, and student engagement. Now the time the Microsoft is working on that virtual classrooms will be there, in which you will feel like that the teachers will be interact with you, and you can directly when you will ask the question, it will look like a real classroom experience will be there. Next one, fashions, the design fashionable clothes that can be done by the also the generative AI will be there. Next one is that challenges in the generative AI. When we go for like first one is that model collapse will be there. For example, the generator will produce the limited variety of the samples will be there. For example, you will write the content from the generative AI like ChatGPT or Brad will be there or Glad will be there, Gemini. In that case, there is certain limitations will be there. Some paragraphs they will write, you will again say that again rewrite will be there, some content will be modified, then again say it will be rewrite. So after some two or for example 4 to 5 times retry, that will you will find out the same type of the content. So we'll say that produce the limited variety of the samples will be there and failing to cover that entire data distributions, that is the model collapse will be there. And for to mitigate, we will require that model architecture. We have to modify the model architecture, and sometime we have to modify the loss functions will be there. These are the first we have to. This particular model collapse can be mitigated from that particular modification of the model architectures. Second one is that training strategy. Either we have to regularization techniques, either L1 or L2 regulation, and some other regulation techniques will be applied. And beside these, some diversity promoting methods will be applied so that our training can be improved and the model collapse can be avoided. So that will be done. Next one is the training instability, means ergodic behavior during the training will be there, that will be render the convergence and performance. The reason behind is that because that is mainly the algorithms we're working on or the gradients will be there. It might be possible that your gradient will be vanish and exploit, and it means your information will be lost. And for that case, you have to readjust the weight will be there and learn effectively. For that case, we have to avoid these vanishing and exploiting gradients. Second one is that model hopping will be there. It means your the network get stuck generating the limited set of the outputs, and that will negating the diversity of the training data will be there. So it possible that your model will be hopping, so you have to again find out that output will be explore each and every possibility of your training data. And most of the time when we have to avoid these problems, so in that case you have to gradient clipping will be there, I mean limited gradient value to prevent that explosion will be there. You have to go for improvised optimization algorithms and regulation methods will be there. These are some mitigation techniques to avoid these vanishing and model hopping will be there. Another challenges is that we have to go for the data biasing. This is an important one will be there because every time we will train some model. In that case, that totally depending upon the input of the data, and these data may be biased. So in that case, the output will be again the biased output will be there. For that case, like for example, when we go for the image generation, that maybe the gender biasing will be there. And similarly, in the language model, the SL biasing will be there. So to avoid these, we will require our training data should be improved. Your quality of the training data will be provided. It means we have to clean the data, and for that case either cleaning will be done, means we have to remove the imbalanced data, and some missing value will be removed, and some provide the diversity, that will mostly done by the data augmentation will be there. For that case either we have to go for the cropping will be there, and rotation will be there, scaling will be there. So likewise, for example, that particular image will be there, and that image will be cropping is the one task will be there. Either we have to rotate that particular rotations will be done. So these means that will be done in our the augmentation. Either the rotation, cropping, clipping, all these techniques will be done in our augmentation. Next one is that algorithmic fairness. It means you have to put some constraint so that it will go for the fairness. That will be avoid the biasing will be there. So during the training phase, you have to apply some constraints so that fairness will be there. And it means that we have to select, we don't select the same type of the tuples during the training phase. We have to random selection of the data from the training from the whole data sets will be there. For it might be possible that your data set is the unbalanced, and just assume that it belong to the one class that have the 90% data and another class only 10% data will be there. If it pick up the whole the data from the class one, in that case totally biasing toward the class one will be there. So likewise, we have to remove these biasing, and post processing will be also find out. Means after we have generated some samples, we have to check whether the some biasing will be there or not. If we are able to find out some biasing in the sample, in that case some post processing techniques will be applied. Yes, we have to modify something will be there. Next one is that ethical implications will be there because we will generate something. Likewise, we have mentioned like deepfake techniques will be there. We'll put the two images and we will provide some action. In that case, some video will be generated based upon these two images, and they will go in some particular area, and that will be go that is not that can be harmful in some particular sense. So we'll say that responsible AI development will be there. We'll not say that we will design some models and it will do each and everything, and that will be do with our the personal data, and which is defamous, and which will use for some extortion will be there, money will be there, and some identity theft will be there. So we design some techniques and tools. In that case, the responsible AI will be there. It means ethical consideration should be there. Implication should be there. And likewise, we'll say like a developer and researchers have the responsibility to be transparent how their generator models will be work, because we will say like yes, that particular translator text generator will be generate the text, but what are the basis behind that particular text generator? When we say that your image will be swapped, on which basis your image will be swapped? So likewise, they have to transparent that yes, this is the reason behind this, or how the our model is working. Similarly, it will share the detail about the data that will be used for the training, and limitation of the technology will be there, biasing will be there, and also the safeguard that it will prevent the misuse will be there, because each coin has the two sides will be there, positive and negative. And most of the time we will go utilizing this technique in the negative sides will be there. So we will also put some safeguard and biasing so it will be prevent from the misusing, and it will be transparent that it will be able to find out the trust and allow for that informed public discussions, and what are the main implications of our the generative AI will be there. So most of the time now that we'll say if we write some paper, in that case we have to provide that detailed model structures, training data, and performance metrics, and beside this we have to also put post the code either on the GitHub will be there or code oceans will be there. In that case, that will be helpful that yes, we are say, utilizing these technique and that produce that particular type of the results will be there. We are not take the hypothetical data. We are not produce that hypothetical outputs will be there. So that is the required nowadays. Similarly, we have to organize the public and public forums and workshops to discuss the benefit and harm, risk always associated with the generative AI. So we have to discuss both of them. And similarly, we have to discuss some explainable AI, how the model will reach their conclusion. What the reason behind this? That is the important one. We have to design this type of tools. Similarly, when we go for the public engagement and dialogues, so it means that will not say that we have designed something, design some AI generative models will be there, and we will not disclose each and everything. So it's we have when we design some tools and techniques based on generative AI. In that case, that should be in some discussions. It means we have to engage our the researchers and community will be there, which for which they have developed, and policymakers and societies will be there, which is very, very important. Because now the time these techniques that will not consider the ethical, and otherwise they will be used in the different directions and they are harmful for the public and society will be there. And it means most of the time when design something in that will collaborating with the policy making will be there. If we now the time you will write the project, in that case they will say that you have to consider the industry, because now the time government does not want to pay you for the hypothetical ideas. They will say that you have to collaborate with the industry so that the real product will be come out. And only industry will say that yes, we will say yes, we want to develop some tools will be there that will be do in that particular task. When we collaborate with the industry, they will say that yes, this type of the tool is not applicable in this scenario, you have to develop in that particular scenarios will be there. So this is the now time will say most of the projects will be rejected, because we have to design the project in such a way that that will produce some either the hardware or software that will be applicable in the real life scenario and we are able to sell in the market. Otherwise the funding will be not available now the day, because previously the hypothetical consideration will be counted that yes, that type of the data will be there, we will design this one. But another time your project should be in the deliverable form, so for that case you have to collaborate with the industry. Next is partnering with the civil society organization to raise the awareness about the potential bias and harmness will be there. And beside these, we have to also engage the public through some educational campaigning and interactive demonstrations. Yes, these are the particular techniques we have don't use in this scenario. Similarly, like a deep fake and disinformations, fabricated media will be there. Impact on our the public opinions will be there, because deepfake will be used to separate that misinformations, and they can influence the elections will be there, damage the reputations, and or the trust in the institutions will be there. So that will be greatly impact on our public opinion. Similarly, there will be also impact on our the we will say in social medias, some realistic highly deepfake images will be generated, and that are harmful in the different scenarios. Similarly, that miscellaneous content will be there, like a cyber attacks. These generate will some phishing emails will be there, fake websites, social media profiles to steal the our public personal information will be there, or our the sensitive information will be there. Similarly, the financial scam. Every time we will say some text will become out, you won the lottery of the 1 crore and something like that. So that will that will create some text AI generated text will be there, which is more convincing. But these are the fraudulent financial documents or websites will be there only to capture your personal information or personal data, so that they will be used in the different ways. Similarly, the hate speech will be there. Those malicious actors will be can generate the AI model to generate their hate speech, and they will separate, they will target some specific group will be there or some individuals will be there. So likewise we will say these are the main problem nowadays when we are using these AI, generative AI especially. So these are will have statistical analysis of the global market is that 10.1 billions will be there. And we have say like these are the image and video generative models. These are the large language models will be there, and these are the multimodal generative models will be there. These are the different scenarios. This is for the image and video. High end V will be there. This is the multimodal will be there. This is for the another portion. So these are the distribution of generative AI market. This is North America, and market revenue is the 40.2% from these generative AI market will be there. This is that trends by the region for 2023 to 2030 will be there. And specific Asia specific market we will say like 37.3% will be there by these 2030, in which we will consider both three things will be there: hardware, software, and services. You will see like when we go for this now we are here. So there are the hardware, similar portion in our the software, similar portion, some more portion on our the services. When we go move on that particular type, in that case, only small increment in the hardware, maximum is the services will be there. Similarly, we have some market distribution, In healthcare, low retail advertisement will be there, and agriculture will be there, automobiles. So there is in each and every field the generative AI that will be impact, and the global market size in the 2022 we have taken here. This is the distribution in the last 2020 will be there, 2022 will be there. This is the 136.5 billions. In the last 2024, yeah, approximately it will be goes for that approximately 20 billions will be there. So like this is the distributions will be there. And next one is that future research directions. When we say like beyond the status quo means we have to explore the new architectures will be there. And as we are using the character AI, we are go for the agent AI will be there. New architectures are developed to enhance their pattern recognitions, and data dependency representations will be there. Transformer reimaging will be there, means evolution of that new attention mechanism, self supervised learning strategy will be there. Similarly, the hybrid approach, we have to merging the generative and adversary model for the deep understanding and improve the realism. Art and design will be there, means collaboration between the artist and AI for the co-creations, and generative art forms will be there. Similarly, the healthcare AI can be used to generate the new hypothesis, accurate drug discovery, and personalize that medical treatments will be there. Similarly, in the social sciences, we can apply by understanding that human behaviors. So for that case, we'll go for the historical data will be there and generate some realistic simulations so that we are able to summarize human values will be there. Thank you. If you have any question, you can ask, please.
Thank you so much, sir. Dear participants, if you have any queries, you can raise. So I guess there are no such queries. So
Okay.
we will share your contact email ID so that if they have any doubts, they can post it to you or they can post it to us so we can forward the queries to you and that will
Okay.
be addressed later on.
Okay. Thank you so
Okay,
much.
sir. Anything else you would like to share about your experience or your knowledge with the participants, sir, then you are most welcome.
If you have any query, you can write the email to me, vijayk@nitj.ac.in. Okay, I will respond to your query within 24 hours if you have any query. Either this particular topic or something else, so you can write email to me. Okay, thank you so much.
Thank you so very much, sir, that you
Yeah,
spared your
okay.
time. Thank you so much.
Okay.
Hey, hi, Dr. Soumya. I hope you're able to hear me.
Yes, sir.
Okay,
Good
so
afternoon. How are you?
I'm doing good. So we have to get started now itself, or you want to take a
Yes,
quick
sir.
break of
Yes,
five
sir.
minutes?
You can start because we have just finished with the previous session and you
No,
can
no.
start.
So I understood
Let
that,
me.
but you
Yes,
want to have a quick break before that for the participants, or we can continue?
I think you can continue.
Okay,
I
sure.
think.
No problem. That's okay.
So you are in presenters list, sir. You can share your screen.
Sure. No problem. Okay, I hope you're able to see my screen.
Yes, sir. It is visible.
Great. Okay, greetings everyone. I hope you are able to hear me. As of now, I'm switching off my camera. I will be switching it on at the end for questions and answers. Right. I've already delivered three sessions, and they were majorly focused around open RAN, and AI ML into the 5G 6G world. However, one of the key interesting area which is acting as a main enabler for many of these things, if I not say most of these things, is going to be cloud, right? So whether I talk about Open RAN or I talk about 5G core network or I talk about AI ML, they need huge infrastructure, right? So to run these things, to run these cloud hyperscale applications, to run the technologies what we are talking about, we need a cloud infrastructure. However, cloud infrastructure also comes with multiple flavors. And traditionally, as we started with the cloud, and which is not really restricted to telecom, it is the overall telecom IT world which used to run on the cloud. And then at a later stage, we started talking about cloud native architecture, and now we are referring towards the telco cloud, right? So for our perspective, for our discussion, telco cloud be more apt discussion, because that's what is going to be the deployment for most of our networks. So whether you want to deploy some kind of machine learning model, or you want to deploy radio network or the core network, you can do it on cloud, right? So you can do it on cloud, be it a public cloud, be it private cloud. I will also show you a few things what we can do with the cloud. So I'll open up one of the VM, just see how do we really deploy our 5G core network, 5G radio network, etc. All those things I will be explaining, right? And we will also outline the difference between the cloud native and telco cloud, right? So we'll understand what actually is cloud, what is cloud native, without getting into too many details, right? So I'm sure most of you have already heard about these terminologies, but just to differentiate, just to understand these things more clearly, we will be talking about it. Now, what is going to be the agenda for our discussion today? We will start with a quick introduction about cloud native, and telco cloud. We will talk a little more about cloud native architecture. We'll also throw some light on NFV and then SDN. NFV, network function virtualization, and SDN is software defined networking. We will talk about it. We'll also have a look at how do we really deploy our core network and the radio access network on the cloud. Or I'm getting some noise from someone, so if you're not speaking, can you please mute yourself? Thank you. Right. So how do we really deploy cloud core and radio network on the cloud architecture? And finally, we'll close our discussion, how this Gen AI is going to make some difference in the telco cloud architecture. Now, let us get started. Let's talk about what is cloud native, and telco cloud. But before I, try to explain it, I generally ask this question to participants, and when I ask what is cloud, right? Typically, the first answer what I normally get is they say it is for the storage. That is the generic answer what I normally get, saying that okay, this is the storage where we can store something. But that concept or that definition is completely wrong, right? So that's not really the definition of the cloud. Now, actually cloud is? Cloud is not really only about the storage. It is a computer in itself. So when I talk about computer, do I talk about only hard disk? The answer is no. When I talk about computer, I talk about output devices, input and output devices, which can be keyboard, mouse, or some kind of monitor, printer, etc. And then we talk about some kind of CPUs, which normally comes with, of course, there can be multiple, just to keep it very high level, which comes with some kind of processors, which comes with some kind of random access memory, and some kind of storage. So basically, the cloud what we are talking about is a computer in itself which have a group of processors, a pooled RAM, and a pooled storage, which is available, which can be shared with multiple different virtual machines. So a cloud is nothing but a computer in itself, but at a hyperscale computer, a computer which theoretically have infinite, because these computing and other things cannot be infinite. Theoretically speaking, that is a kind of infinite, we call it, and that is why we say that okay, cloud is provides you infinite amount of data, storage, processing, etc. Right. Now, This is the starting point. This is the starting point where we have started virtualizing our infrastructure instead of using a physical server in our premises, which is typically referred as on-prem servers, on-prem servers, right? And we were just building these infrastructure, these application in our premises itself. We have moved to something called as public cloud or maybe the private cloud. We'll not get into the details of the service model or the infrastructure model or deployment models of cloud. There can be public, private, hybrid, community cloud. There can be infrastructure as a service, platform as a service, software as a service. Right? I'll not get into those details. I'm assuming that most of these things are already known by you, or maybe you are already aware about, or maybe you have read about all these things. Right. So that's not really we are going to get into details, but we will focus more on the cloud native, telco cloud, etc. So just to just highlight this, the cloud is nothing but a computer. And why normally we call it as a virtual computer? Because it is not reachable by us. It is available in a place which is completely isolated. We cannot really touch and feel. That is why we call it virtual. Nothing is virtual. Even though you want to store a bit, either 0 or 1, you will need a hardware to do it. Without having a hardware, forget about storing millions or billions of GB of data. Even you cannot store a single bit. Even to store a single bit, 0 or 1, store that bit or process that bit, you need to have a hardware. That is the idea what we have in the computing. Now, what is cloud? It is basically a broad term which is used for computing services. The computing services include storage, processing, RAM, networking, etc., which can be delivered over the internet. Generally, when we refer this, whenever we talk about cloud, we generally refer this to public cloud, but that's not really the only type. There is another type which is called as a private cloud, which can be created as a closed environment for a given enterprise. But in the public cloud space, there are leading companies like AWS, GCP, and Azure. AWS, Amazon Web Services, Google Cloud, GCP, and Azure, which comes from Microsoft. And these three put together have almost 50% stake, more than 50% stake of the total cloud market. Right. What type of key characteristics we have? We have on demand access to the resources, on demand access to the resources, pay as you go pricing model. So when you go to AWS, they normally offer you some free tier, right? And just to take an example, they have different way of doing it. AWS gives you some services for 12 months free. GCP gives you $300 credit, 300 USD credit. So basically, uh, based on my experience, I'm saying your experience may be different. I have used GCP more than AWS because AWS puts a lot of restriction in using the resources. However, GCP gives you free access to many of the, I'll not say all of them, but many of the services with a price of $300, which is approximately 25K INR, 25,000 INR, and that is enough to do everything, enough to do everything what you can do in the experimental phase. It may not be sufficient to run your commercial workloads, but it is good for doing anything which you can do with the experimentation. So they, and anything beyond that, so this 300 USD, 300 USD, if you go above that, then you have to pay as you go. So they provide for different type of services. They charge you either per GB or per second of runtime and a number of other different billing mechanism they have got. And to check all these things, they normally also offer you something called as TCO calculator. TCO, total cost of ownership. So they also give you some calculator. Okay, this is going to be the total cost for my resources. These clouds can offer you scalable and flexible infrastructure. You can go global in minutes, right? So if you want to launch one application today in America, you can do in minutes. Forget about months or weeks or years. You can do it in minutes with the scalable and flexible infrastructure. These can be public, private, hybrid, multi-cloud, hybrid cloud, community cloud. They use different type of deployment models as well. Hybrid cloud, multi-cloud, and a number of the different terminologies they use. What can be the example use cases? You can use it for data storage option, like you do in Google Drive, like you do in Dropbox or maybe OneDrive. You can also use it for web hosting by running some kind of AWS EC2 or VM instances in case of GCP. They also provide you some cloud-based applications like Salesforce, Zoom, Teams, Meet, etc., which are just so this is option where you can use this as a IaaS, or you can also use this as a PaaS. This is an option where you have SaaS, software as a service, infrastructure as a service, platform as a service. So these services can be consumed in various different formats. These services can be consumed in various different formats. The way you want to do it, you can use it. Now, what is cloud native? Originally, when we started, building cloud, these cloud were, sorry, not the cloud, but the applications were not specifically designed for cloud. They were just some traditional legacy applications. And instead of hosting those applications on bare metal server, people have started hosting them on a cloud infrastructure. However, cloud gives you a lot of flexibility and a lot of modern practices, which can be really beneficial for the next generation of applications. And some of these includes like microservice architecture, containerization, for example, using Docker for container, using orchestration like Kubernetes, and using the techniques like CI/CD, continuous integration, continuous deployment, and DevOps, etc. Right. So these are some of the next generation practices or next generation possibilities which can make your cloud environment very impactful, and you can actually exploit the maximum benefit of the cloud infrastructure. That is what we call it as a cloud native. What are the key characteristics? It comes with a microservice architecture. Now, we will also take an example in terms of 5G core. How do we really deploy this microservice architecture in the 5G core? If you remember, I mentioned that earlier, in case of 5G, we have 24 network function and we have 102 microservices. So just to take an example, AMF as one network function can have 6 different microservices. So basically, the AMF is not built as a single entity, it is built as a collection of 6 microservices, and we normally refer is a suite of services. So they are basically providing a suite of services which can be provided to provide used to provide some kind of specific functionality like AMF. So a collection of my services or a collection of these APIs will make your network function, and that is referred as CNF. CNF or Cloud Native Network Function, or sometimes we generally also call it as a containerized network function, right? So the applications are broken down into small independent services, and that is referred as a microservices architecture. These applications are packaged in containers so that they run consistently in different environments. I'm not really getting into too many details. We will at a later stage, we will talk about virtualization and containerization as a topic. But as of now, these microservices or applications are built or the package in the containers. And then we use tools like Kubernetes for the orchestration, because generally these containers will be in the number of hundreds or thousand depending on the application. So you will be running 100 or 1,000 containers, and managing those containers may not be possible manually. So in that case, you need to bring in some kind of orchestration tools like Kubernetes, where you will be able to manage these containers and deploy them, scale them, etc. And last but not the least, providing resiliency, where these applications, these containers can fail, but they can be restored very quickly. So they can actually handle your failures very gracefully. That is what is the benefit of it. What can be the example use cases? Building one application using Docker or Kubernetes, which can scale across various cloud platforms. The enterprise, which are adopting DevOps practices for faster application development and deployment. Moving on to our next discussion, telco cloud. Telco cloud. Telco cloud is a specialized cloud infrastructure which is tailored for telecommunication network. Now, what are the typical requirements of telecommunication? Telecommunication network have their own requirement, right? We want to have, some faster latencies, high reliability, some 3GP specific interfaces, the communication related to radio network, core network, OSS, BSS, and a number of other things. Now, what we are trying to do is we're trying to fine tune the cloud infrastructure based on some kind of, telco applications, which can be some kind of core network, radio access network, OSS-based system, etc. Of course, using the principles like virtualization and containerization. So what can we, it supports network functions. As I mentioned, all the network function in the core network, they are some kind of CNFs, containerized or cloud native network function. In Open RAN, your CU, your DU, your REC, all these things can be as a CNF, can be as a cloud native network function. So even sometimes we also refer to VRAN, VDU, VRIC, etc. These are virtualized one, so they can be virtualized to reduce any hardware dependency. Now, what type of requirement we have? We have requirements like low latencies, high availability, etc. that can help us to meet these requirements. Another interesting area for future generation is going to be edge computing, where edge computing is generally offered into some kind of telco cloud kind of architecture, which is sitting on the sitting on the base station site and giving you the faster responses. What can be the example use cases? Can be 5G core network on a telco cloud platform. We will look at an example at a later stage, or vRAN or virtualized RAN, which can be managed using the telco cloud. vRAN or open and deployment using telco cloud. Now, let us try to get little more detail about the cloud native and what are the expectations we have from the cloud native. Just give me a second. Let me take a sip of water. Okay. Now, before we move to this, let us talk about traditional network elements. And I'm talking about the time till 2010 or 2012 in telecom world. Till that time, all the telecom network elements, we used to call them NEs, network elements. Why network elements? Because they used to have dedicated hardware on some bare metal servers. And the software used to be a monolithic application, and that is tightly coupled with the hardware. What does that mean? That the software running on this hardware cannot run on any other machine, and this machine cannot be used to run any other software. So hardware and software are so tightly integrated. It is like Apple MacBook, right? So you cannot run Windows. Okay, there are some workarounds, but in general, right, you cannot run a Windows on an Apple MacBook, and you cannot run uh, Apple MacBook iOS on any other Windows machine, any other vendor machine. So they were tightly integrated with each other, and that makes it difficult to scale. And to do all these things, they used to have complex configuration to deploy, scale, and manage these kind of devices. This is the scenario what we used to have in the traditional architecture. But how these networks has evolved over a period of time. The hardware-centric network has started moving towards the software-centric networks. The physical network elements has started becoming VNFs or CNFs. The interfaces were all, I'll not say vendor specific, may not be the right statement throughout, either vendor specific or telecom specific interfaces. Like we used to have SS7, we used to have GB Link, we used to have n number of different interfaces, but all telecom specific interfaces and protocols. But now we are talking about open standard APIs, which are running on the protocols like HTTP2. So we are moving towards the more open infrastructure in terms of communication between the network function. They are actually created as some central offices, MSC location, etc. And now we are having those things in the as a data centers. The manual configuration, most of these configuration and management used to be manual, and now they are moving towards more zone kind of architecture or self-organizing networks. Hierarchical network, which is typically was the traditional architecture, and now it is moving towards the distributed cloud architecture. All these hardwares used to be vendor specific hardware. So when you buy a base station from Ericsson, you have to buy the hardware, software, and all the support from Ericsson only. Nobody will be able to provide you that. However, nowadays they come as a white boxes. And if you remember, we were talking about telecom, ORAN Alliance. We were talking about ORAN Alliance. ORAN Alliance have a specific group just to do the standardization of white boxes, white box hardware. White box hardware means a open COTS hardware, right? The network used to be physical network. Now we are talking about logical network sectioning, which is typically referred as slicing. These networks were primarily designed for only telecom driven services. And now we are talking about industry and the user driven applications. Now, let us have a quick look at NFV and SDN before we talk about the difference between the virtualization and containerization. Now, as I mentioned, this picture comes from the Etsy Mano architecture, and this is called as NFV. And normally, you will see people in the industry talking about NFV or VNF as interchangeable terms. So sometimes for the same thing, they will call it as NFV. Sometimes they will call this as a VNF. Then what is the difference? What is NFV? What is VNF? Let us try to understand that. The NFV is the process. NFV is the process. And VNF is the output of that process. So let us take an example. I have a product called as MME, which is called as mobility management entity, or you can even refer this as the AMF or anything else for that matter. Now, what I do is they were generally traditionally they were designed with some kind of purpose-built hardware and with the tightly integrated software. But now I do a process called as NFV, network function virtualization, and the output of that is VMME, virtualized MME, and this VMME can be referred as one of the VNF, virtual network function. So basically, the process of creating these VNFs, which is the virtualized version of one network element called as MME. The process is called as NFV. The complete framework of this is defined in the HC menu architecture. So NFV is a framework which is using the IT virtualization technique, and basically the whole idea around it that we have to decouple the network functions. We have to decouple the network functions from the software, decouple the network functions from the proprietary hardware so that we can deploy those things as a software. Now, to look at it, this is the infrastructure part where you have the computing, storage, networking, etc. And you use one manager here, which is called as VIM virtualized infrastructure manager, which runs on this virtualization layer, and then create a virtual computing, virtual storage, virtual networking. On top of that, we can use these virtual storage network or computing to create one of our VNF, and on top of that we deploy our applications, as we will see later. How these VNFs can be created, they can be managed, they can be terminated. The whole life cycle is managed by the VNFM, Virtualization Network Function Manager, VNF Manager, right? And this VIM and VNF, they are controlled by NFV orchestrator, and NFV orchestrator reports to something called as OSS BSS, Operation Support System, and the Business Support System. Now, the VNF, the product is the virtualized network function, which can consist not one, but one or more virtual machines. Some of these things can be located in different centers, different servers, and they can still represent the same network function. Or it can be having some kind of containers running different softwares and processes on top of standard high volume servers, right? This is done instead of using a custom hardware appliances for each network function. So when you have AMF, SMF, UPF, UDM, UDR, PCF, and all those things, you need not to deploy a separate network boxes. And you can understand this. If you look at 4G network architecture, you will see one box, you will see two box, you will see three box, you will see four box, and you will see five box. In case of 5G, these boxes become 28. Now, sometimes you may feel that, hey, why we are making our network architecture so complex when it was very straightforward earlier. But that's not the case. Because in this case, when you talk about these boxes, every box was a physical hardware with the integrated software. The 28 network function, what I'm talking about in 5G, they are the collection of microservices. So basically, we are dividing these functions, and that also helps us to have many benefits, which includes the scalability, that every network function can be independently scaled. At the same time, it gives you a lot of innovation. Earlier, if you want to add one more feature in MME or one more functionality in MME, you can't do it because for doing this, you have to replace the complete MME. However, today, if you want to add one more network functions, you just need to deploy one more network function with some microservices. The scalability and the innovation, the pace of innovation becomes very fast, and that is why we have gone for this kind of architecture. So even though these looks like 28 network function with 102 services, they are not really the hardware, they are the softwares running on its central hardware, maybe data center or maybe some kind of COTS hardware. Now, the SDN, the whole idea around SDN is separating the control plane and user plane, control plane architecture and the user plane architecture. So basically, disassociate the control control plane from the data plane. And this control plane, what you created here, can control more than one user plane, So basically, this control plane here can control more than one user plane, right? So we can have multiple user plane connecting to the same control plane. What SDN controller is? So basically, the SDN controller connects to multiple forwarders, give them some kind of guidelines, and these can be called as flow table. And if you remember, this kind of architecture, what we use between SMF and UPF. SMF takes care of control plane, UPF takes care of user plane, and SMF gives some kind of PDR, packet detection rules. SMF gives some kind of PDRs, packet detection rules, to the UPF, which are like flow table. Please remember, I'm not saying that SMF and UPF are just the SDN product. I'm just saying they follow the similar architecture like SDN controller and the forwarders, right? So they have the similar architecture. And if you know, in the release 14 of 3GPP, we implemented something called as CUPS. Even before 4G, even before 5G, I'm saying we implemented one architecture called as CUPS architecture, which is called as control plane and user plane separation. CUPS, control plane and user plane separation, where we separated the HGW, PGW as two entities. One is called as control plane entity, another one is called as user plane entity. Now, a quick comparison between SDN and NFV. SDN separates the CP and UP, control plane. This actually virtualizes your network function. This can be used for campus, data center, cloud. This is mainly used for the service provider network. This can be used for commodity server and switches. This can be used for any network, 4G, 5G, any other network function. What type of application like cloud orchestration networking? They can be used for gateways, CDN, WAN, accelerator, and even 4G, 5G product. SDN uses a protocol called as open flow protocol. Open flow protocol, but NFV doesn't have any specific protocol. The standardization of SDN is done by ONF, Open Networking Foundation. This is done by Network Function Virtualization or NFV group in the ETSI, European Telecommunication Standards Institute. Right. Now let us talk about service-based architecture, and we'll not get into too many details because we remember we have already talked about this a bit when we talked about 5G core architecture. 5G core architecture. So the complete 5G core control plane is based on some kind of service-based architecture. It is based on some kind of service-based architecture. Now, in this service-based architecture, there are two different type of semantics. Either you request for something, or if you request something, you get a response, or you subscribe for something and get notified. Let me give you an example. Let's say you want to buy a Apple MacBook with M3 chipset. Apple MacBook with M3 chipset. You can go to any Apple store. Right? Request them that you want to buy M3, make the payment, and get your M3 MacBook right away. This is one way of looking at it. Let's say you are looking for Apple MacBook with M4 chipset, which is not yet launched, which is planned in mid of 2025. So what you can do is you can do a pre-booking, and pre-booking also either you can pay some amount or you can just put a request, say whenever it is available, just notify me. As soon as this event will happen, the store is going, because you're subscribed for this event, the store is going to send you a alert saying that, hey, M4 MacBook has arrived, request you to collect that MacBook, right? So basically what I'm trying to convey here is this kind of architecture will allow us to either request for something and get it right away, or subscribe for something which can be delivered at a later stage. These are the two different semantics what we use in the service-based architecture. Now, let us talk about virtualization and containerization. In virtualization, what we have got is, and if you look at the overall architecture, it will not look very different. It has a minor difference, and we will discuss the difference. You have a multi-core processor, which you can refer as a CORS or bare metal server. CORS stands for commercial off-the-shelf server. On top of that, we have a host operating system, which may or may not be there depending on the hypervisor type we are using. There are two hypervisor 1 and hypervisor 2. Right. So one of them, like hypervisor 1, they don't use OS operating system. 2, they uses the host operating system. Right. Now, after using so what is hypervisor? Hypervisor is the abstraction layer. Which converts these physical hardware into some kind of virtual entities. Convert these physical hardwares into some kind of virtual entities. Now, after creating the virtual entities, let us take an example here. So you have 1 second. So let's say this is made of storage, CPU, networking, and RAM. What you have done here is, after using hypervisor, this storage is broken down into smaller virtual units. CPU is also divided every vCPU. Network interfaces are divided into smaller pieces. RAM is divided into smaller pieces, half GB of RAM. Now, what you're going to do is, you are going to pick and choose some storage, some processing, some memory, and some networking resources, and you have made your computer. You have made your computer. Now, when you make this computer, to run this computer, you also need a operating system. You need an operating system. And on top of that, you are installing some software, some application, and put together all these three things. It becomes your VNF. So for example, this can be AMF, this can be MME, this can be HSS, this can be SPGW in the 4G. I'm assuming that you all are aware about the things what I'm talking about. Like these are different network functions, 4G or 5G network, 5G architecture. So basically, sorry, basically VM is a collection of the resources which are available as a virtual unit. Of course, they are running on some physical units only. That hypervisor works like a abstraction layer which can convert your physical resources into some logical resources. Now, what are the challenge with the VNF? Let me ask you a question. When you install Ubuntu in your computer, it can be anywhere between 2 to 5 GB. So that means this operating system will have 2 to 5 GB of storage requirement. And whenever you boot your operating system, it takes anywhere between 1 to 5 minutes. It will take minutes, right? So because of this, VM becomes a little heavyweight thing, and they take time to restart. And whenever there is a failure, to bring in new VM takes time. To avoid these kind of problems, we have moved to another architecture which is called as containerization. If you look at the picture doesn't look very different. And you will see that you will have multi-core processor with a cache. I will talk about it. And on top of that, we have a host operating system, which is going to be typically a Linux kind of operating system. On top of that, we have container engines, which is similar to the hypervisor what we were discussing in the previous slide. And this container engine, in this case, we can call it as a Docker. Docker can be container runtime. In the similar process, the way we did it, we have got some storage, some memory, some networking resources, some RAM, and we have created CN1, container 1, container 2, container 3, container 4. On top of container, if you see, there is no operating system. It just have some kind of dependencies and libraries, and they use the same operating system which is running as a host operating system. So these containers don't have their own operating system. They typically run with the kernel operating system. And on top of that, you can deploy your microservices, and a collection of these containers can become your CNF or cloud native network function. Now, Because of this architecture, these containers, they normally are in the KBs or MBs, unlike VM, which used to be in the form of GBs, right? And because they are not rebooting their operating system, they are running on a kernel operating system which is already booted, they can come up in seconds very quickly, right? So basically, the container, whenever a container is failing and we have to build another container, it takes a second to get that up and running. So that is the kind of speed what we get. And because of this, containerization platform are becoming more popular. These applications are becoming more popular than compared to the traditional VNF kind of architecture. However, just to compare both of these things, so this is the same thing, container orchestration. To manage these hundreds of containers, we need Kubernetes kind of things. Now, just to compare here, for legacy client server application, this kind of architecture may be good. But when we want to run cloud native microservice based architectures, then this kind of architecture we have to go. One interesting point here is this COTS hardware for your container architecture may not be independent server. Maybe one of your VM is also working as a COTS hardware. So what I'm trying to convey here is they are not completely independent. Maybe your containerized architecture, what we are talking about, may be running, containerized architecture which we are talking about, may be running on a VM itself, right? So even though I'm using VM as the base hardware, on top of that, I can build a containerization architecture. I hope this makes sense. If you have any question, please feel free to drop those questions in the chat box. We will be taking up those questions at the end of the session. Now, these are some of the principles where we talk about microservices, containers, continuous delivery, DevOps, etc. And then this is the overall stack looks like, where we have the various VM. It can be a physical host, it can be VM. On top of that, we have a container host. Container host is nothing. Lekha, can you please drop your question in the chat box so that you don't forget? We will take those questions at the end of the session. On top of that, we are running some kind of container runtime, which is typically the most popular one is Docker. And on top of that, we have containers, and those containers will have a lot of different applications, including container networking, cluster management, service discovery, container scheduling applications. So some of the leading, one second. Okay. Some of the leading, what I was saying, sorry. Some of the leading certification the the Kubernetes, they are all done by Linux Foundation. And they are called as like CKA, CKD, right? So these are some kind of certified Kubernetes administrators, certified Kubernetes developer, etc. So these are some of the leading certification if you want to get into the world of cloud native and containerization, etc. Now, moving towards our discussion, how do we really deploy our core network, radio access network on the cloud native architecture? Right, let's talk about it. Now, if you remember, traditionally, when we talked about this, one second, initially we had the EPC. EPC stands for Evolved Packet Core, where we used to have architecture like MME, HSS, PCRF, SGW, PGW, and connecting to the data network. And then we did something called as CUPS. In CUPS, one network function is divided into two parts, CP and UP, control plane and user plane. And that is what called as a control plane and user plane separation, which is referred as CUPS. Now, what we did here is we had divided HGW into two parts, HGWC, HGWU, PGWC, PGWU. However, we have not done this for the first time. We call it cups for the first time, but we have done this similar thing multiple times in the previous releases as well. Why we do it, how we do it, I will not get into those detailed discussion because that will take a lot of time. right? Just to understand, we want to, what are the benefits we get out of it? We get a better scaling, independence creation, and distributed allocation in the resources. That these are some of the benefit, and the kind of edge applications we are talking about, that edge applications what we are talking about in our networks, that is primarily possible because of the cups architecture. If you don't have cups architecture, deploying those edge applications is going to be very difficult, if not impossible. I'm not saying it is going to be impossible, but it is going to be very difficult if you don't have the cups kind of architecture. So if you want to see the edge applications, you will see that your user plane is deployed at the base station itself, right? That is one of the benefit what we get from the cups architecture. Now, in case of 5G, the architecture, the HEW and HEWU and PGWU becomes the UPF, the control plane becomes the SMF, MME becomes the AMF, HSS becomes the AUSF, UDM or UDR, the PCF becomes the PCF, and with this we got this architecture. So with this, we have got this architecture where all these network functions, what we see here, they are created as a service-based architecture, which can be deployed on a cloud-ready architecture, right? So basically, this doesn't include, there are network functions like NSSF, NEF, NRF, which are completely new to 5G. They were not there in the previous generation. So 5G had three different type of network functions. The first type of network function, which were, you know, which are used just as a new network function in 5G. Some of them which are upgraded, and some of them which are completely new. These are the different network functions we have in case of 5G. Now, how do we really deploy this AMF, AUSF, SMF, etc.? To understand this, first of all, you need to go to technical specification, which is 23.502. This is a 3GPP specification talking about the 5G core network architecture in detail. In that, if you go somewhere around page number 540, you will see all these network functions defined there, the network functions and their services. The network functions and their services. Right. Now, when you deploy this, when you look at this, you will see that every network function is a collection of microservices, and this is how these microservices looks like. Sorry, 1 second. I think quite difficult. 1 second. By mistake, I have copied same slide 2 times. Right. So this is how these microservice looks like. So basically, these are the containers which are created with Docker, orchestrated with the Kubernetes. On top of that, we are hosting or deploying some kind of microservices. Now, if you see, there are 100 of different microservices which are involved, and a collection of these microservices are the network functions, which are referred as CNF or Cloud Native Network Function, which are CNF or Cloud Native Network Function. So this is basically the architecture of the cloud native deployment of the 5G core network. At a later stage, we will see how do we really deploy. There are at least more than 50 projects which are available, which can help you to deploy all these things with the open source products on a cloud native architecture or any Ubuntu machine. You can install in any computer, or you can even deploy. If you don't have a computer, don't have a good computer, you can even deploy it on a cloud infrastructure, and that's what we are going to see. Now, this is just the repetitive of the same machine. In case of OpenRAN also, we can have OCloud. OCloud is nothing but a CORD server. OCloud is a commercial off-the-shelf server which is available. Just give me a second. And this server can be used deploy your ODU, UP and OCU-CP, or near real-time rig, or a combination of these. So basically, you can have one O cloud to deploy your ODU, another O cloud to deploy your OCU-CP, OCU-UP, another one for near real-time rig, or you can use any combination of these things, and these are called as open-end deployment model. Open-end deployment model. And the near real-time rig, if you remember from our prior discussions, the near real-time rig have some kind of XApps, and no real-time rig have some kind of RApps. XApps or RApps, even they can be deployed as the microservices in these architecture. Even they can be deployed as microservices in these architecture. So the whole infrastructure what we are talking about today, there are a lot of open source, like for example, SRS-RAN, which we are going to see at a later stage, can be used for deploying your CU and DU, and they can also deploy some ZMQ libraries to have a RF interface between the UE and the radio unit as well. So many of these things you can actually deploy in your architecture itself. Now, moving on to the next discussion, where we talk about AI and Gen AI in telecom cloud. Why we are talking about this telco cloud in the space of AI Gen? First of all, we need to understand that even when we talk about AI or Gen AI, they need a infra. They need an infra. And that infra itself is also built on top of cloud, if not the telco cloud, at least the cloud, right? So to train your model, to build your model, to test your models, you need to have data and you need to have processing or the GPUs. And that is also mostly built on some kind of cloud infrastructure. I'm not saying public cloud, it can be public or private cloud. You need a massive scale of the infrastructure, which is not easy to build in your own site. Just to take an example, we recently got a requirement from a customer saying that, okay, hey, we want to know how to build our own LLM related to telecom and how to train our model. And they wanted to do this as a 5 days training with a budget of, say, around 5 lakh rupees. But one thing they were missing to build this LLM, the normal budget will be somewhere between 5 to 10 million US dollar. Right. So even though it's easier to say, okay, I want to build my own LLM or I want to train my own LLM, this takes massive time and investment. That is the kind of energy, that is the kind of bandwidth we need to build these kind of things. Now, what can be the use cases of AI Gen AI in the telco cloud, where AI or Gen AI can be used to do the network automation and optimization, which can help us to have some kind of dynamic resource allocation, traffic analysis, load balancing, etc. So the in cloud in general and telco cloud to be specific, we use some term called as orchestration, which we were doing from last few slides. The orchestration itself requires a AI/ML in place. With the AI/ML only, orchestration becomes fruitful. This can also have some kind of predictive maintenance where AI can detect anomalies and predict equipment failures, reduce downtimes and the operational costs. It can provide some kind of service assurance and customer experience, which can be based on some kind of Gen AI chatbots for automated customer support, or provided AI provided some kind of QoS monitoring. This can also help us to have efficient 5G 6G deployment, which can help us to have better network planning, simulation, or maybe generative AI create codes and deployment configurations. So when we want to build all these build these deployments, it can help us to create those codes and deploy those specific things. Now, what are the benefits? It is going to improve our efficiency because manual intervention will have a lot of human errors and a lot of challenges. It will provide, even though even AI and Gen AI is not foolproof, they can have their own challenges. But overall, it is going to improve our efficiency. It is also going to enhance our agility. where I create some kind of cloud native AI models which can actually adapt to the network demands in the real time. Because of these kind of architecture, our cost can be reduced by doing some kind of predictive analysis, which is going to manage your CapEx and the OpEx, capital expenditure and operational expenditure. It's also going to improve our scalability, where we can scale the resources depending on the workload and traffic, and it can also provide us personalized customer experience. Now, it also comes with its own challenges and solutions. The challenges will be integration complexity, because these AI models has to be harmonized to these telco cloud architecture, and that requires some kind of some intensive work on those areas. It can also provide you some challenges in terms of data privacy and security, where you can safeguard sensitive customer and network data, and skill caps. These are some of the areas where the skilled resources are not available, and that can be one of the challenges. What can be the solution? Solution can be the use of open frameworks. Use of open frameworks that includes Kubernetes or ONAP kind of architecture. Use privacy preserving AI techniques like federated learning. And upskill the workforce through targeted AI plus telco cloud training or telecom training, etc. Right. How the future outlook of telco cloud and AI Gen I look like, where, and we have already talked about it, we are hopeful that the future generations are going to be completely AI native, where the autonomous networks will be driven by AI or Gen AI. 5G and beyond network, the complete network orchestration, edge computing, everything will be controlled by the AI. Revenue streams, this will also bring some revenue streams with the network slicing as a service, edge services, IoT related services, enterprise services, etc. And that will also help us to create new innovation hub to include algorithm design, use case discovery, etc. And if you remember, recently Government of India has funded another 100 labs, and they are in process of deploying another 100 labs as well, right? Sorry. And these 100 labs are designed to have some kind of use case discovery. Call to action. Invest in telco cloud and AI talent and infrastructure today to shape the telecom of tomorrow. Excuse me, can you please mute yourself if you're not speaking? Okay, great. Now, we have also seen some kind of transformation in the 5G deployment also, and these transformations are going to continue in the 6G as well, And for that, we are referring to the next-gen deployments of 5G. Initially, the traditional 5G network architecture, they have used a central cloud. They have used a central cloud, which is used for deploying your core network. And then we have edge cloud, which was owned and operated by the MNO, mobile network operator, which was given to you from the companies like Huawei, Ericsson, Nokia, and they give you the DU, CU, DU, and RU, and the interface between them are used to be proprietary interfaces. So there was a closed infrastructure on the radio network side of it. After that, we move to deployments like Rakuten Japan, which is one of the fourth largest operator in Japan, where they have opened up the interfaces between DU and RU. So they have started deploying the radio access network itself on the CORDS hardware, and started moving towards the CNF kind of architecture in the core network itself. Now you see, your DU and CU are coming from the LTO star, and your radio units are coming from NEC, Airspan, Fujitsu, etc. And in this case, at a later stage, LTO star itself was acquired by Rakuten, and now it became Rakuten Symphony. However, even to build such a use infrastructure with the CORD servers will require you a lot of money. So you need to have a lot of money, a lot of deep pockets, very, very deep pockets to deploy this much infrastructure. If you're a new operator, that may not be a great choice. So the another operator, Dish Wireless, which was the fourth largest operator in US, they have gone for a different approach where they have deployed the radio network and the core network, both radio network and core network on AWS. So all their infrastructure is hosted on AWS, but they just buy the radio from the companies like Fujitsu, MTI, etc. Now, you may ask, hey, deploying core network is okay, but how do we really deploy these units at the cell site? For that, AWS also provides you the AWS also provides you the a server rack, and this server rack is typically called as AWS Outpost. What we are going to see, in the next couple of slides. What type of deployment what we may see in the 6G network, right? And in 6G, we are moving forward from the cloud native architecture to the AI native architecture, where we have a virtualized network resource pool. We have a virtualized network resource pool, which is creating a lot of AI instances, Please note, as of now, 6G standards are not frozen. So as of now, we are at least 4 or 5 years away from the 6G standards to happen. So these are more of the imaginary things, artistic impressions, you can say. Normally, when you buy a flat, they say, "Na, this is the artistic impression." This is more of a artistic impression. What you see, where you have just like your containers. Now we have a lot of AI instances running. Of course, they will be running on some kind of containers itself or some kind of similar identities. On top of that, so a collection of these AI instances is going to serve one application, a collection of another application, another AI instance is going to serve another one, and another one is going to serve the another application. So basically, your 6G deployment may have a lot of AI enabled. Please remember, AI instances here means nothing but the containers deploying some kind of application, and these all applications can run independently to provide a better user experience. So what are these AI instances? They will have some kind of caching resources, some communication resources, some computing resources, training manner, AI algorithm, etc. And this is more of a imagination what we have got into it. How we really deploy it, how all these things will be created, that will be yet to be seen. Now, how the AWS Outpost looks like. This is how the AWS Outpost looks like. This is nothing a server rack powered with the AWS services. Okay. Right. So that's all for this session. And before we close the session, let me show you some or the other things. For this, I am just going here. Okay. So if you see this, we have this SRS RAN project where you can deploy your radio access network, core network, etc. in various different options. So let me just go back. SRS RAN project documentation. I'll directly go to the documentation. And when you see this, they have various different installation options, right? So if I look at installation guide, let me see. Okay. These are the different options. You can do this SRS RAN Gnode V with SRS UE, CORDS UE with Amarisoft UE with DPDK, Kubernetes, Endover, Gnode V with 5G NTN, CUDU split, 7.2 split, near RTRIG, XApps, MATLAB testing tools. So there are lot of different options available, and I have already deployed. So similar to this, there are multiple options. So let me give you an example here. Let me come to this 1 second. Right. Okay. Second. Yeah. So let's look at some options. So we have, let me change the color. For the core network, we have option as free 5GC, we have open 5GS, we have Magma Core. For the UE plus RAN, we have options like UE RAN Sim, UE RAN Simulator, we have SRS RAN, we have OAI. Here also we have OAI 5GC and open air interface, right? For the orchestration, we have multiple options, but then we have Magma Core, which can also provide you orchestrator and NMS. So you can create various of these configuration. You can create at least 100 different projects by implementing some of these things. And there are hundreds of projects which are openly available, which you can try to consume. And even if you go with the SRS, this SRS RAN GitHub repo, you will be able to see lot of different projects. Now, I have also built a project with the SRS RAN project here, right? And it allows me to log in into somehow in the morning, in the afternoon when I started it, the Docker of this setup has crashed, right? So it's not working. But if you see this, in this particular architecture, I have deployed 5G core, G-Node B, and UE. And let me clear it. ls minus L. So if you see this, I have, just let me go to /root. So I have deployed SRS project here, SRSN project, where we have SRSN config file as well. So I'll say cdc srsran config file ls minus L, and I do cat gnode B. So you see this is the complete gnode B configuration. Get UE. This is the complete UE configuration. So all these configurations are available. When I go into this, clear here, EWD, LS, I go to SRS and project, sorry. So these are the different directory where you can see app, what are the builds, what are the CMake, what are the different configurations, Docker, all these things will be available. So similar to this, you can also deploy Open RAN. You can simply deploy Open RAN and start using it as well, right? So there are a lot of different options what you see here in terms of tutorial, and many of these things are also available on the GitHub as the free repo where you can do end-to-end deployment. So for example, if I want to go with the SRS UE, so it shows you the complete options. So it runs on PC with Ubuntu 20.20, SRS RAN project, SRS RAN 5G. If you want to do it with the, some radios as well, you can also run with two ATAS USRP B210. It is deployed on the Open 5GS by using a library called a 0MQ library, which can be used for some kind of radio simulation. So complete all the details are mentioned here. So you can follow step-by-step method and then deploy it on your own architecture. So this is something which is freely available. And if you're interested to learn more about it, and even before you started to work with 6G and things related to that, you should try with at least one or two of these kind of setup, and that will help you to learn these things as well. Now, how do we really create virtual machines? As we spoke earlier, you can simply go to I'm using GCP, Google Cloud. So I'm just going to start with the VM creation, just loading. So I give, one second. I give the name of the VM as say MUJATAL, our program, what we are doing here. You can choose where you want to deploy this application. So you can deploy it in India, in some other country, in Europe, depending on where are your target audience. So for me, I want to do it in Mumbai, and they have multiple availability zones. So I can go with one of the availability zone. They have variety of different instance types. So these are the different families. like C4, C4A, which is depending on what type of things you want to do. Some of them are for high performance, some of them are for GPUs, some of them for low cost day-to-day computing and things related to that. And after doing all these things, what you can do is you can choose, even for E2, there are multiple options. You can go with, say, 1 vCPU or 1 GB memory, 2 vCPU, 2 GB of memory. Or maybe what you can do is you can go to the custom, where you can say, I need 8 vCPUs and maybe 16 GB of RAM. Right. That just to take an example, I may not do it. So I'll go with 8 GB of vCPU, 8 GB of RAM. And it also tells you what is going to be my monthly cost. What is going to be my monthly cost? So in this case, my monthly cost is going to be approximately $174. Monthly cost is going to be $174. So if I go for 1 week, the cost will be approximately $50. Approximately $50, right? And that also includes some kind of hard disk. If I increase the size of the hard disk, it is going to further increase. If you want to look at the advanced configuration, it also give you a lot of advanced configuration related to this. And then moving to next, what OS you want to use. So by default it is using Debian, but if you want to change it, instead of Debian I can go for, say, Ubuntu. In Ubuntu also I can choose which option, whether I want to 20.0, 20.04, 22.04 or 24.04, what type of disk it has, what is the hard disk I want. For example, instead of 20 GB, I need 30 GB. And when I select it, now I am using the Ubuntu operating system with the 30 GB of hard disk. And my cost, I think it's almost the same, nothing very different, but it has added some $3 extra for the hard disk. What type of networking you want to do, and finally, so you want to allow which type of traffic, want to enable, disable some of the capabilities. And finally, when you do it, you can go for the observability, security, how you want to secure it, advanced, right? All these things you can do. And once you're done with this, you can create it. So your VM will be up and running. So your VM will be up and running. On top of that, you follow these steps one by one, one by one, and you can deploy your radio network, core network, as well as the user. It is not going to be easy. You may not be able to do it in one go if you're doing it for the first time. It takes a lot of time to learn all these things. They also have all these things available on the GitHub. So you can go to their GitHub page and you can see this is the Open5PS repo, which is created end to end. Right. So you just need to follow the steps here, and then you can use it one by one. Right. So that's a quick introduction on the telco cloud and things related to that. I'm open for questions. If you have any questions, do let me know, and I would be more than happy to answer those questions. Dr. Soumya, I hope that session was okay. If you have any questions or any participant have any questions, somebody has raised their hands. One second. Lekha, can you please ask your question? You have raised your hand. Or anyone else, if you have a question, please feel free to drop in the chat box, or maybe you can raise your hand and we can unmute you. Any questions from
Yes,
anyone?
sir. It is.
Yeah.
Yes, it is open now. And if anybody has any query, they can drop the query in the chat box, or they can directly ask you.
Yeah. So I think it was a long session for them, right? So maybe they are tired, right? So, but still, I think Lekha has raised her hand. So if she has some question, maybe I'm not sure if it is by mistake or something. If she has some questions, she can ask, or anybody else have any questions, they can ask. I'm open for questions. Any questions from anyone? Okay, so I've dropped my email address in the chat box. If any questions from anyone, please feel free to drop me an email. I would be more than happy to answer those questions. So it looks like there are no questions. So if no questions, we can close the session. When is the next session planned? You have another session after this? Okay. So
I
that's one.
guess there is no such query because
Mhm.
um, I think there are no queries, and if there would
Okay.
be anything, we will drop you, sir.
Sure, sure. No problem. Yeah. Thanks a lot. Yeah. That's okay.
So if there is anything you want to share, you are most
And I
welcome.
think it
Otherwise,
was a pleasure. Thanks for giving me this opportunity. It has been my fourth session, right? And I really enjoyed it. Right. Thanks for giving this opportunity, and I'm looking forward for any future sessions. Whenever there is some need, feel free to reach out to me. And it was a good discussion with all of you. I hope you enjoyed this as well. If you have any feedback, good, bad, any constructive feedback you want to improvise these sessions, I would be more than happy to answer those things as
yeah,
well.
sure, sir, sure,
Yeah.
sure.
Yeah.
Thank
Yeah,
you
thanks,
so very
Soumya.
much, sir.
Thanks, Rob. Thanks,
Okay,
Mr.
sir.
Arvind. Thanks,
Have a good
Soumya.
day, sir.
You too. Take care. Yeah. Thanks. Bye.
Okay, bye bye, sir.
Bye.
So, participants, it was really a very nice and informationful session, and our next session will be started in 7 to 8 minutes. So, stay connected. We'll write back with our next speaker.
जी हमें इस चीज का पता चला तभी तो हम इनसे मिलने आए बाबू हीरो हीरोइन के तुम शायद सिक्स पैक अंदर बाबू हीरो
हे प्रभु हरि कृष्ण जगन्नाथ को ये क्या हुआ? सिस्टम चेंज
Good evening, ma'am.
Hello.
Yes, ma'am. Very
Okay.
good evening.
Very good evening.
So I have made you presenter, ma'am. You
Mhm.
can start the presentation.
Okay.
And before we start the presentation, if you allow, can I have a short introduction of yours with the participants?
Yeah, yeah.
So, dear participants, for this session, we do have Professor Dr. V.V. Mani with us. She is a professor at NIT Warangal. She has done her BE and ME degree from Andhra University and PhD from IIT Delhi. She joined NIT Warangal in April 2008 as assistant professor in EC department, and now she is professor over there since March 2022. Currently, she is heading Computer Center NIT Warangal as an additional duty, and she is serving as Associate Dean, Staff, Training and Recruitment. Prior to joining with NIT Warangal, she worked as a software engineer, Capricorn Global Solutions Private Limited, Hyderabad. Worked as assistant professor at Gitam University and full-time research associate at IIT Delhi. Her area of interest include wireless communication, signal processing for communication, optical communication, and design of real-time testbed for 5G using SDR. She has more than 100 papers in credit in national and international conferences and journals. She has supervised 9 PhD students, and currently 5 more students are working with her. She has completed 6 projects and 2 more are ongoing with DST Serb, UK IERE, Spark, India Asian with international collaboration. She has visited many countries and presented her research papers. She has spent 3 months at RICE University, Texas, USA, under Research Exchange Program. Dr. Mani and her research team developed a wireless communication laboratory for MTech Advanced Communication Systems using SDR platform. She is a fellow of Institute of Electronics and Telecommunication Engineers, that is IETE, India, and senior member of IEEE. So thank you so very much, ma'am, that you are here for this talk. And the audience is all yours. You can start the talk, please.
Yeah, thank you so much. Just give me a minute. Joining with another device as well.
Yes, ma'am.
So, how many participants are there?
Yes, ma'am.
How many participants are there?
Ma'am, there are 53 participants right now in the
Okay.
meeting.
Okay. And from which section, like, are they EC background?
Ma'am, actually, we have not analyzed that. It is an open FDP. It is
Mm-hmm.
ATAL FDP, AICT sponsored.
Okay, okay.
So it is expected that majority of them are faculties from
Mm-hmm.
multidisciplinary backgrounds.
Mm. Okay. So, because my talk is based on the wireless communication, I hope they can understand, because the other discipline people maybe just see what to do. Can they ask them to write their specialization in the chat box? So anyway, I'm sharing my screen.
Yes, ma'am, you please share your screen because right now your screen is not visible to us.
Yeah, yeah. The screen.cast. Is it visible now? Can you see my screen?
Not yet, ma'am.
Mm-hmm. Yeah, I shared my screen.
Uh,
Dot broadcast. Yes. Is it visible?
Yes, ma'am.
Yeah. Let me join with my tab
मैम
as well.
अभी screen display तो हो रहा है but it is showing the screen broadcast. If you go back to the presentation window or the because your screen is clearly visible and it is showing the Teams itself.
Yeah, I shared my screen.
So you just open the
Yes,
presenting. Yes, ma'am.
is it visible now?
Yes, ma'am. It is clearly visible now.
Okay, okay. Just give me a minute. I'm joining with another device. Please allow me to join.
Let me know, ma'am, with which name you are logging in.
Yes, 1 minute. With the same name.
With the same name. Okay, ma'am. Please join.
Yeah. Okay. Just give me a moment. Okay. So is my voice is clear?
Yes, ma'am. Your screen is visible to us and your voice is clearly audible.
Okay. Okay. So good evening, participants. I welcome all you to the this workshop, ATAL FDP. So actually, I have given my topic for to Professor Dhaka about visible light communication for 6G. Right? Maybe the title I put in a different manner. But I wanted to know how many of you are from ECE background before going to with this talk. Any chat box they can type?
Yes, ma'am. Dear participants, as the speaker has a small request about your inputs, about your background, please drop your background, your technical background in the chat box, please. Everyone, be fast so that after taking the feedback, ma'am can start the session. Please drop your technical feedback. Everyone, just drop the feedback, technical background. Very nice. One participant, that is Dr. Kusumlata Jain, she has dropped, ma'am. She has the technical background of sensor networks.
Okay, okay. Anyway, so I had to start my session. So coming to this visible light communication, I just wanted to give what kind of a work we are doing at NIT Warangal, and then later in detail I'll present how to model this visible light communication for 6C. Okay. So to begin with this visible light communication, the kind of a work what we are doing at NIT Warangal, just look at my slides. So I want to just show the demonstration of the system how we have developed in our institute, in our lab. So we can see that the same light, LED light, what we are using at our homes can be and with a photodiode. So because one is a transmitter and one is a receiver. So here I am showing one transmitter, one receiver. So my transmitter is right. So you can look at my pen where I am putting my pen. So here it is. I made a circle. So this is it visible, clear to everyone? Okay.
Yes, ma'am.
Yeah, someone please keep on give her in feedback by what? Through chat box. That will be easy. Okay. So now you can see that we have used a light LED. So this light actually we have taken from one of the LED lamp, and we broke one of the LED lamp and we took one LED out of it. And also if you look at the other one, So where I am keeping my cursor, so this is my photodiode, right? So LED transmits the light and photodiode receives the light. So one we have used as a transmitter, another one we have used as a receiver. So transmitter and receiver. So to build this kind of a setup, we have used two systems. One system as, because it is a software defined radio platform we have used. So one system is in one system we have installed LabVIEW. Another system also we have installed a LabVIEW, the second system. So this I'll call it, this is my transmitter, this one is my receiver. So we write all our signal processing codes like modulation, format, sync formats, any codes for channel correction and source coding, everything we write in your MATLAB, in your LabVIEW, that's similar to your MATLAB. So this is a LabVIEW software provided by National Instruments. So this we have used as a transmitter source and a receiver. So to the transmitter source from LabVIEW, we write all the codes. We dump all the codes onto ESRP, transmitter ESRP. I put a tick mark. So TX ESRP, right? This ESRP generally has, I can show you the ESRP diagram. This is the ESRP, is also bought from National Instruments. So this ESRP has RF section and RF section, ESRP X300, ESRP X400, ESRP X200. So many versions of ESRPs are available. We have all the versions of ESRPs in our lab. We got it through our projects. And so if you look at this ESRP, there is RFA and RFB. That means I can use one as a transmitter and receiver, and one as a receiver. One as a transmitter and receiver, another one is a receiver. So see, this one is a receiver and this one is a transmitter receiver. This one is a receiver and transmitter and a receiver, right? So that means I can use model this one as a MIMO system as well. So what we did, so these knobs we connect with an antenna system. So that the signal is radiated into the space and will receive the radio signals. So this transmitter ESRP and receiver ESRP, if you look at those knobs, what we have done, we just connected the source. That means my LabVIEW output is connected through a wire to the transmitter ESRP. This is my LabVIEW output connected to ESRP. Then we haven't used any antenna. So what we have done, we placed a diode, that is placed a diode in place of the antenna. So we used a circuit diagram which drives the current to the diode. That is at transmitter section. Now look at the receiver section. So we have used a receiver ESRP. So and we know very well your diode must be driven through some current. So we used a regulated power supply. This is RPS, regulated power supply. And even photodiode also needs some current drive. So we have used those current drives to this diode and photodiode through a regulated power supply. And also we have used a biased circuit, bias T. If you look at this diagram, there is a bias T. So bias T which divides the current between these two places. So that means the transmitted ESRP output is given to this taken that code and we have given to this diode, and from there some regulated power supply is also given. So we have designed our own bias T circuit. Then come to the receiver. So the receiver is now, so nowhere you have seen the antenna connections, right? So ESRP antennas are removed, and from that port, whatever the radiation value of the signal is coming out of that port is directly given to my system. So I have taken this value using an USB, and that is given to the LabVIEW software. So this in the LabVIEW software, I can see the outputs, right? So this means I have to decode the signal. Like first, I'll remove any channel coding is done. Then I'll remove the formats of any noise. That means I'll design my demodulators. Everything I have to write my codes in the in the LabVIEW section. Then I can see the figures, what I transmitted, what I received. So if you look at the transmitter diagram, constellation diagram, I am showing in a wider scale. If you look at the transmitter constellation diagram, so just look at a transmitter diagram. This is a BPSK case, one simple case we are showing. So this BPSK signal is transmitted, and so in the receiver side, we can see the receiver signal in the lab view. So PC. So this is corrupted with additive white Gaussian noise, and we have tested this one for a very short distance case because the photodiode what we have used, the area of receiving the signal capacity is very less. Otherwise, we can use it up to 10 meters. That depends upon the capability of the photodiode. So we got this photodiode from Thar Labs, imported, and it is the cost is around 75,000 rupees, and rest all the instruments, ESRPs we procured from National Instruments, and LabVIEW also we have procured from National Instruments. So this is a setup, that means the software defined radio based setup which we established at NIT Warangal to show the transmission. Wireless communication is possible through light, right? So this wireless communication is possible through light. So we have used two ESRPs. One ESRP is N210 is used. Another ESRP is the 300 is used. Now, so if many of the faculty are aware about the synchronization issues between the transmitter and receiver. So when you send a packet, the packet has some pilot information because we want to track exactly where I have to start my receiver, right? So that means, so if you look at the in-phase data of the received packet at the receiver, we will see that there is some kind of a gap is there, right? So at this point, initially there is a kind of a gap, then we would see a burst of a signal. So this amount of misalignment of the signal, that means when you transmit and when you receive, there is a receiver window. It can track the signal after some misalignment. That means we have to do some synchronization. So what kind of a synchronization you have to keep between transmitter and receiver such that my starting window of my receiver is same as the starting window of my receiver. Or my transmitter is already started. I am just observing at the receiving window. So the receiving window will start decoding the signal after tracking with the after tracking the difference between the amount of the signal, then it starts decoding the signals. Okay, so this will do a lot of signal processing aspects in LabVIEW, how to track, how to demodulate, way to demodulate, and everything. We write codes in the software to track this information. So there is at least there is a gap of I would say that is not some 1 millisecond gap is there between the transmitter signal and the receiver signal. So here we have studied a PAM signal as well for a 4-PAM. So this 4-PAM, the received signal has lot of noise is added around the received signals. Lot of noise is added around the received signals. Okay, so we use our signal processing techniques to eliminate this AWG noise and the channel noise and other any multipath channel noise is which is coming through the coming from transmitter to the receiver. Then we decode. We give the signal to the decoder. The decoder will map the received signal into bits of zeros and ones. So this is our kind of a setup what we have used at our institute. Now look at this one is for 4-QAP. That means QPSK signal. So the QPSK signal has 4 constellation points. 1, 2, 3, 4. So we have passed through the transmitter and through the same setup. If you see, the received signal has 4 constellation points in the receiver terminal. And we map to zeros and ones bits. Okay. So this is done at SNR of 20 dB, the received constellation for 4 PAM. We have done at SNR of 20 dB. And not only this, modulation techniques, we have used some aspects of synchronization. We have used some aspects of other formats of how to code my signal, and so many signal processing algorithms also implemented. It's very easy because we need to see the transmission and reception in a wireless manner. So whatever you can develop in the software. And those developed data is just given to the USRP, not just given to the USRP, there are some protocols. Okay, those are given to the USRP. USRP generates the transmitted signal and it gives to the antenna. In place of an antenna, we have used a diode. So some of the references we have taken. This is one basic work what we have done at NIT Warangal. So not only this basic work, we have seen that 5G testbed design using OFDM, using GFDM, using OTFS signal formats. Okay, so now I'll go to the actual presentation. What is this VNC and how it works. So in this kind of a work, maybe I can talk about a little bit about waveforms and the channel estimation and peak to average power ratio analysis in our VLC system, and DST based multi-carrier systems and synchronization issues. Okay, so as we know, because the tremendous growth of mobile devices and unpredictable data access over the wireless channels, the spectrum is already overcrunched. And so we are looking for the alternative technologies like optical wireless communication, OWC is emerged. And this optical wireless communication is also very cost effective because we use only optoelectronic devices like light emitting diodes, that is visible. So one of the technologies is visible light communication. And also the major advantage with the use of this visible light communication, it uses a license-free bandwidth and it's ranging from 380 nanometers to 780 nanometers. And definitely it will become a complementary to RF-based wireless communication. So now I'm showing the basic diagram of my VLC system. So we understand how my signal is to be transmitted from one end to the other end without any wires. Okay. So if you look at this basic VLC system model, the all other block diagrams are same as your wireless communication except a diode and a photodetector. So, and before the diode, we have used a driver circuitry and a dimming and a photodetector and optical filter. And so photodetector output is amplified output is given to the demodulator. So the sections, if you look at each section of this VLC system, we have an information source, encoder and modulator. And in the receiver section, we have demodulator, decoder and data destination. These are all similar to your wireless communication model, and channel anyway will be there. So instead of the channel, we are writing it as an optical, after signal is coming, and we are mentioning that optical concentrated, but signal falls on your photodiode to be collected, then it is given to the detector. Okay. So anyway, we haven't used the optical concentrator. So this optical concentrator we have not used. This block is not used. Only even optical filter is also not used for our experimentation. Just after the driver circuitry and even dimming circuit is also we haven't used. So this is a generalized system model I am explaining. We have just used only driver circuitry, LED, and it is just LED output is a light. So it comes through the channel, the wireless channel, just it falls on a photodetector. Okay. So these, the circled block diagrams are not used in our system. And even amplifier is also not used in our system. Just we have used a LED circuit, LED and driver circuit and a photodetector. So only with this we could show our transmission of the signal is possible. Okay. So the basic concept behind this visible light communication system is, we know very well, the diode conducts only in the positive direction. Everyone knows, right? So that means if you give a positive signal, it conducts. If you give a negative signal to the diode, so then it is reverse biased, so it won't conduct. But in our case, our signals are in the form of waveforms, right? So the 0 bit or a 1 bit we translate into a cos form for wireless communication transmission. So I make it as a positive cos, I'll transmit. For a negative bit, I'll transmit a negative cos. For example, if you take for a BPSK case, if this is my signals are to be transmitted, then can you imagine that if I am giving this cos or a sine signal to my diode circuitry, what will happen? So during positive half cycle, the diode conducts. During negative half cycle, diode could not conduct, right? So then what happens to my information? So I cannot retrieve my original information, what I am sending, or my diode circuit, because ultimately the final source of transmission is only diode. So diode, when it is conducting only for half and not conducting for the another half cycle, that means a negative cycle. So the format of the signal, what is transmitted to the diode, if I am sending a cos, it will be half, and there will be another half, there will be another half, like this, right? So the remaining dot values are missing. So then I cannot retrieve this one because I use a matched filter or I use a correlator receiver to receive the signal. So if I use a matched filter or a correlator receiver, what generally I use, I make the received signal is multiplied with again the same cos. So cos, I'm not explaining with the whole mathematics. A general example I am saying, cos 2 pi fct, suppose if you multiply, this is half pulse cos and this is a full cos. So this multiplication result into a wrong answer. But whereas if both are same cos, then that means cos square 2 pi fct. So that cos square 2 pi fct can be written as 1 plus cos 4 pi fct, right? And when you integrate over 0 to t, so this goes to 0 by 2. So then that means 1 by 2 and times t. So something like that. I'll also use 2 by t. If you all know the digital formats, then t gets cancelled out and 2 is also gets cancelled out. So finally I'll receive 1. That means if I am sending a 0 bit, I'll receive a positive 1. If I am sending a 1 bit, I'll receive a negative signal. Something like that, or vice versa also. That depends upon what you are transmitting. So this system is not possible if you use a diode as a transmitter. Then what you do? You have to change the format of the signal according to your digital modulation techniques. So for that, we use for visible light communication different modulation techniques. So these are different modulating techniques. We have to change them. That means my entire cos signal, what I am transmitting over a single bit of time period, I have to shift it to I have to add some bias value so that it is shifted. Let's take, I have shifted to 10 volts. Upon 10, I am making a cos signal, something like this. Now, this entire signal has become positive, so it can be passed through my diode. So we have to change the formats of your modulation techniques. If you are using different modulation techniques, according to each modulation technique, I have to change my signal format. That is a new addition to visible light communication, where we could publish good number of papers. But now almost all this area is also has become saturated and many papers are already published. Only experimental work is remaining. And during the daylight, so the light, when the light is transmitted during the daylight, the sunlight also falls on your photo detector. So that means a lot of disturbance is happening to the received signal. So that kind of a problem still is remaining. So people are working on that problem, how to avoid the turbulence noise That means the daytime noise. But at night, so this system is working very well. Only the day, during daytime, how to eliminate the sun rays uh, using an optical concentrators and optical devices. So the lot of work is going on experimental basis. Otherwise, in a mathematical format, so most of the work has been published in many of the good journal papers. And also the implementation wise, yes, the practical implementation of this protocol, the stack layer, the network layer, a lot of scope is there for this kind of a work. In physical layer, most of the work is already completed. So the different kinds of modulation techniques what we can use for transmission of this signal is, I can use a single carrier modulation technique like on-off keying, pulse width modulation, pulse position modulation, and in multi-carrier modulation techniques like OFDM. And in the OFDM, so many variants, DCO, ACO, PAM, FLIP, hybrid varieties, ADO, HO, and so on. Other multi-carrier modulation techniques, WPDM, HCM, real transforms, DHT, discrete, Hermish, DCT, DST, cosine transform, sine transform, so many transforms, and color phase shift keying is also can be used as a modulation technique. So, but mostly for high data rate communications, the 5G is adapted OFDM. So we would like to continue with the OFDM because the limited bandwidth of the bandwidth available for the LEDs, and also this orthogonal frequency division multiplexing is adapted by 4G and even extended to 5G. So we tested our system with using orthogonal frequency division multiplexing. So are there any doubts till now? Please give your feedback in the chat box.
Okay, ma'am, please continue.
Okay. So to make my signal a real format and also to bring it to the positive axis, we have imposed an Hermitian symmetry criteria to the input of the how many of you know OFDM from this group of people? Maybe you can open your mic and give your feedback.
Participant, please answer the question. How many of you are knowing OFDM?
Most of us know OFDM.
Okay. So if you know OFDM, so OFDM signal is a complex signal if you take wireless communication scenarios, right? So now we have to make it into a real valued signal. What I said earlier. So if you are sending a cos, the cos half is cut off by my diode. So I have to bring it the another half also to above of my zero axis. So for my OFDM, so OFDM is working with analogous with your IFFT and FFT diagram, IFFT and FFT block, right? So IFFT and FFT are nothing but your fast Fourier transforms and inverse fast Fourier transform. So this fast Fourier transform and inverse fast Fourier transform are similar to your ortho. That means so many signals we are transmitting in parallel formats. So if you remember, suppose x of t or x of n is a signal, x of n is a signal. If I am asking you to compute the Fourier transform of my signal in time domain, so this Fourier transform, the x of n, discrete Fourier transform will apply some k n equal to 1 to capital N e power minus j 2 pi k n by capital N, right? So we multiply with e power j's. E power j's means cos plus j sine, right? Cos of x plus j of or minus of j of sine of x. So this cos plus j sine format is in complex domain. So, but my LED takes only the real format. So that means you have to make these formats because anyway I have to use IFFT block. for transmission and FFT block for the reception. So even this IFFT also, it takes x of s and the summation e power plus j2 pi k n by capital N, right? So this is also takes e power j. E power j means cos plus sine. So this cos plus sine is a complex format. But the output of this FFT, I cannot directly give it to my LED. What I have to translate? I have to translate this output of my FFT into a real format, and after real format only, I can pass it through my die. So to make into the real formats, we can use an Hermitian symmetry technique, which makes a complex domain signal into a real, convert into a real domain signal. And this visible light communication is very much helpful in our smart to make our cities smart, because so many of the cities are already deployed with LED lamps. So while walking on the roads, we can use any public in place of a Wi-Fi. If you can provide this kind of a transmission, visible light transmission, we can provide Wi-Fi through these smart lights. Okay. So that is one of the advantage, and also so many other applications are also, we can place them for placing in the signals, integration of LED with the transportation infrastructure, integration of LED lighting system in the vehicles, so that when vehicles are on road, they can predict how much distance each one is placed, is there any traffic congestion. So those things can be can be transmitted through these light scenarios. So even if you want more about this theory on concurrent illumination and communication, a survey on visible light communication. So this was published in Physical Communication. It is an Elsewhere SCA journal. So she is my student Sushila and me. So this is nearly a 30-page document, a journal paper. So what we have done, we have compiled all the information available in different journal papers, and we wrote one survey paper. So it's a very good survey paper. So even if you want to start your research, if you want to extend this research with other modulation schemes, other formats, and nowadays people are talking about RIS, intelligent reflecting surfaces, right? Or IRS, intelligent reflecting surfaces, where they place on top of the walls. So in the hidden buildings, the signal cannot go. Then in such um, fading systems, we can use RAS. The signal passes through RAS. This RAS